The question 16, the first one in the writing part, is similar to the example 9.1 and 9.2 from lesson 4.9. It is about the marginal cost and the average cost. 9.1 is about marginal cost. Before we begin this problem, let me tell you what exactly is marginal cost. So imagine you cook something, say a piece of cake. Okay, you're making cakes. You want to sell the cakes, and there are six cakes. Okay, one, two, three, four, five, six. Imagine they are identical cakes. Say brownies. So to cook the brownies, you need oven. You need, say electric supply. You need storage and all that, and you need flour. You need milk, sugar, and all this, right? So you have all these for six brownies, for exactly six you have. But what if you want to do one extra cookie? I mean, brownie. The seventh one. So the oven, the electric supply, the utensils, which are already the fixed cost, won't matter. They'll be there even for the seventh one. You don't need to again pay for these things. But you don't have any flour remaining, you don't have milk, you don't have sugar. These need to be bought in for the seventh one. The replenishable items required for the extra item or the product is basically the marginal cost. Now, over here, when X is 100, see over here, there is a company which produces X units, and this is the total cost. We need to find the marginal cost for the X 100. That means for the 100th unit, for this cost equation, for the 100th unit, how much will be the replenishable cost? That's the marginal cost. And we have to compare that to the actual cost of producing the 100th unit. So let's do this. It'll be step by step. First is step 1. That is marginal cost. What we will do is, the marginal cost is given by the derivative of the total cost function. All we need to do is derive the c dash of x, or c prime, prime means derivative, or you can also call it as dash, will be equal to 0.02 multiplied by 2x, derivation of x squared is 2x, plus 2 plus 0. So the derivative over here would be equal to 0.04 x plus 2. I hope this is clear. It's 0.04x plus 2. Now what you need is to find the marginal cost at x is equal to 100, isn't it? So c prime of 100 will be 0.04 times 100 plus 2. Here only this x value becomes 100. Then the remaining things are same. It's 0.04. I've just messed it up over there, but here it's clear. And now what? Just compute this. It'll be 2 zeros, 1, 2. It'll be 4 plus 2. That is 6 dirhams. 6 AED is the marginal cost. Very simple. Whenever you have been given an equation, just find its derivative. That'll be the c prime of x. That is the marginal cost equation. So you need to substitute the x value given to you, and all you will get is the marginal cost. That is the step 1. Please write it down because we will have to do the actual cost and compare it as well. So the step 2 is the actual cost. Now, how would you find the actual cost? Let me consider this equation, or you can, because this is the total cost equation, we can put any x values and you'll get the total cost of producing so many units. Say you know the cost of producing 10 cakes, okay, 10 brownies, it costs you 100 dirhams. And you know the total cost of producing 9 brownies is 90 dirhams. So if you subtract these both, what happens is you'll get 10 dirhams. So we can find the cost of the 10th brownie by subtracting total how much we require for 10 brownies subtracted by the 9 brownie cost. That's it. So same way, what we will do over here is we will find the total cost of 100 units and then subtract it by 99 units, then we will get the 100th unit. So it is C of 100, because we are dealing with total cost function. C of 100, just use this function, minus C of 99, that is the cost of 99. That's it. Then we will get the 100th unit cost. That is the actual cost. Now then, C of 100 would be, here in this equation, all you need to do is type out x as 100, the whole square, plus 2 times 100 plus 4000. And the answer will be, you can just compute it. And then over here it is of 99. What's gonna happen? It's the same thing, but instead of 100 we have 99, and over here it's 2 times 99 plus 4000. That is equal to something. Now then what we do is actual cost, that is equal to C of 100 minus C of 99, that is equal to the two values you need to subtract, and then you find the answer. So let's use our calculators and solve it up. Here, instead of typing this out 199 each time, you just need to type the given equation, that is 0.02x squared plus 2x plus 4000. Now just calculate at any given value. What do we need? Calculate it at 100. Sorry, it's not 200. 100, and the answer is 4400. So over here we get 4400. And then change this with 99. Calculate it at 99. So we get the value of total cost produced for 99 units, that is 4394.02. So all you need to do is subtract this 4400 minus 4394.02. It is 6 and not 6, sorry, 5.98 dirhams. So that is it. Now you can just do it in the calculator. 4400 minus the previously stored answer. The answer will be 5.98 dirhams. Now let's compare. The last step was to compare. If you compare the marginal cost, it was 6 dirham and this is 5.98. It's almost equal. You can just write it's almost the same. So these two are very important, the step 1 and step 2, finding the marginal cost and the actual cost, and that is it. So here we can see through the solution as well. We get these two. So note it's very close to the marginal cost. Also note is the margin. Okay, there's one more thing. Marginal cost is always very easy to compute, whereas to find the actual cost took us a long time, right? Finding the total cost of 100 units, subtracted with 99 units, and then you find it. But the marginal cost is very, very easy to find. Now we need to find the average cost. Now again, the same function is given, but how do we do the average cost? Let's do step 1, finding the average cost. And then it's not only that, they have given this equation, and then we need to see the company has to produce X units of a certain product. Find the production level X that minimizes the average cost. This is very important. We need to minimize the average cost. That means we have to find the increasing, decreasing, or the maximum and minimum. So, from the critical numbers, we can find this. But before that, to find the difference between the two problems, whenever they have given you average cost, generally the units will be in terms of X. Whereas marginal cost will be in terms of, they'll give you 100th unit, 50th unit, something like that. Here then, what you do is find the average from the cost function. Average is given as C bar of X. Now, how do we find this? See, the cost of 10 cakes is 100. There are total 10 cakes, right? N is 10 cakes, 100 dirhams. What is the average cost? You divide it by N, that is 10. Here it will be 10 dirhams. That's the average cost. Same way, to find the average cost of this particular function, when they produce X units, it is just C of X divided by X. Now that is 0.02x squared plus 2x plus 4000 divided by X. How much will be the average cost of this function? We'll get 0.02x. I'll split it out and then I'll do it in stepwise, plus 4000 divided by x. So the average cost function would be 0.02 square, and this gets cancelled. It'll be only 1x, plus x cancels. It'll be only 2 over here, and 4000. This is in the denominator. When I bring it up to the numerator, the power changes. It's 1, it goes up, changes its power to minus. If this was minus 2, when it goes up, it would have been plus 2. So this is the average cost function. Okay, step 1 is done. Now we need to find the critical numbers. So step 2 would be finding the critical numbers. Critical numbers. How do we find the critical numbers? We need to derive the given function, right? We need to derive the average function, not the given function. Average function, that will be 0.02 plus 0 plus. So now what happens over here? We have negative x power minus 1. So this becomes minus 4000, and minus 1 will be minus 2. So let's make this equal to 0 equals 0.02 minus 4000 x power minus 2. Now there are different ways to solve this. One way would be taking this down to the denominator, it will be positive 2, and take it to the other side, divide 4000 by 0.02, and then take the square root. Long method, but the calculator method would be easy. The only issue is it might take some time to get the answer, but you will get the answer. So all you need to do is type it out. 0 equals 0.02 minus 4000 x. Shift and solve, and then press equal to. Now it's x power minus 2, which I realize now. Shift and solve, and then press equal to. It'll take some time, and press again equal. Okay. Now you might, you know, in your calculators it might take much more time, but just be patient. Once you get the answer, press equal to. This is the correct answer. See, this is the correct answer. When you press equal to, it must be the same. It should not change. So it is 447.2, but since it's a product, we can't take decimal values. It should be a whole number. So x over here is equal to 447 units. Now step 1, step 2 is done. What is the step 3? Step 3, I'll write it over here, is minimum x value. Minimum cost, the x value which is required to minimize the average cost, isn't it? So what I'll do is, see, there are different ways. You can even directly find the second derivative, use this x value, solve it up. If it's positive, it is maximum. If it's minus, there are various ways. But what I always do is this value. Why? Because it's easy to understand, and the shortcuts which you just derive again and then use the x values might tend to confuse you during the exam. But this one, drawing out, easily solving up, it's very easy, you know. So let's see, the x value is 447. More than that, it goes until infinity. Here it will go until minus infinity. But since we are dealing with products, some units, we can't take negative values. We have to take from 0 to 447, 447 to positive infinity. And what is this function? This function is about the derived function, the average derived, that is dash of x. Now here you can choose any value less than 447. I'll choose 400, 446, anything, and more than this, 500. We need to know whether they are positive or negative. So let's take our calculators again. Here, this equation, which is that equation over here, 0.02 minus 4000 x raised to negative 2. Let us calculate this at what? I can just choose 446, and you can see it's minus. Or let me choose 400. Look over here, it's a minus. So this is minus at the left side. What about the right side? What if I take 448? Look over here, it's positive. Calculated at 500 units. It's positive. So this means here we have minus, here we have plus, isn't it? So it's going down and going up. Yes. Therefore, x is equal to 447 is minimum value, is the minimum. Is enough a value, you can write it. Or you can just write the same question is right over here. The production level x is equal to 447 to minimize the average cost. Or you can just tell x must be equal to 447 to minimize the average cost. So that is how we solve it. And the x value must be 447, and then we will get the minimum cost for this particular equation. Over here, we can see the same thing. We require x is 447, then we will get this cost function, the minimum. And you can see over here it's dipping until 447 units, but then it keeps on increasing as well again. So somewhere over here is the minimum most, and then it goes up again. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will solve mathematical and real life problems on related rates. It's from the lesson 4.8. Here we have a real life problem. Suppose a 6 feet tall person is 12 feet away from a 18 feet lamppost. You can see over here in this figure. The first question is, if the person is moving away from the lamppost, that's this right side, at the rate of 2 feet per second. So it's along the horizontal axis. dx by dt with respect to time is 2 feet per second. So it should be second here. At what rate is the length of the shadow changing? This is the length of the shadow. See over here, the s value. We have to find ds by dt. What is that? And the part B will do it later. So what is given? Since it's the writing part, let's write given. We have dx by dt. This can also be written as x dash or x prime of t with respect to time, because everything is changing with respect to time. His movement is with respect to time, it changes this distance. And the shadow also changes with respect to time. That's why we write over here with respect to time, that's bracket t, or dx by dt. That is given as plus 2 feet per second. We need to find ds by dt, or you can write it as s prime of t. That's the thing. And what do we know? Now the solution. Here, if you look carefully, this is like this similar triangles. There are two triangles inside. The angles will be same, and this is 90 degrees, so this is a similar triangle. And we can use the relationship of similar triangles. What is the bigger triangle, outside triangle? It's x and s, isn't it? So we can write x plus s this side divided by, what is this, 18 divided by 18. That will be equal to the inner triangle, that's s, divided by, what is this height, is 6 feet also, it's 6 feet divided by 6. Now we will simplify 6 1 times and 3 times, and let's multiply this 3 to the other side. It'll be x plus s is equal to 3 times s. Take this s to the other side, it'll be x is equal to 3s minus s is 2s. But now we do not want these values, we have to find the derivative, okay, differentiation, because we have the value of dx by dt and we have to find ds by dt. So let's do implicit differentiation on both this side with respect to time. Let me just write it over here. X is equal to 2s, isn't it? Now let me derive this side, dx with respect to time dt, that is equal to, see, what is the derivative of x with respect to x? It will be 1. But with respect to time, it will be, this is basically dx by dx, that is equal to 1. But here now, d by dx is not there, it's with respect to time. So we just write it like that, or x prime with respect to time. This is how we write it. So here dx by dt is equal to 2 times. Now ds by dt, that is the shadow changing. Take the 2 to the other side, it will be half of dx by dt is equal to ds by dt. Now, what is dx by dt? We have the value, it's 2. That's half times 2 is equal to the rate of change of the shadow. That is dt cancels off. Your answer is 1 is equal to ds by dt. That is the rate at which the shadow is changing. It's 1 feet per second. That's increasing. Why? Because he is going towards the right direction, right side. Now the second part is repeat with the person 6 feet away from the lamp post and walking towards the post, towards this lamp post at the rate of 3 feet. I'll write it as x prime of t. It's the same thing, but it's minus this time. Why is that so? Because it's coming towards it, so 3 feet per second. So it's negative. Here it's the same situation. All we need to do over here is this part. I'll just change that one only. The new value is half times minus 3 is equal to ds by dt. So here it will be negative 1.5 feet per second. That is the rate of change of the shadow for the second case. Why? Because they have told is coming towards. So that must be the answer. Let's look into the answers. Now here the answers are wrong because they have chosen some different values altogether. The given value is not 2. It's considered to be 0.5 here. And next one, it's considered to be, minus 1. But the other methods are same. You can refer this till over here. It's just that the given value is considered to be erroneous over here. That's the reason we get the wrong answers. I hope it's clear. But whatever I've written over here is absolutely right. So just follow this and that'll be more than enough. We'll move on to the next problem. In this problem, we have been told Boyle's law for a gas at constant temperature is PV is equal to C, where P is the pressure, V is the volume, and C is the constant. Assume that both P and V are functions of time. Show that P prime with respect to time divided by V prime with respect to time is equal to minus C by V squared. Basically, we have to just find the derivative over here. So what we'll do is P times V, that is equal to C, right? We'll derive this on both the sides. Here, remember, we have to use the product rule. If you have A and B, that product of the whole derivative, when we derive this, it's going to be A prime B plus AB prime. So here it's going to be P prime with respect to time times V plus V prime with respect to T times, this is going to remain as it is P over here. That is equal to, what's the derivative of a constant? It's 0. It can be any number, it'll just be 0. Now we'll divide everything throughout by V prime. Why? Because we need P prime divided by V prime, isn't it? V prime of T. Now that is obtained over here, and V prime of T here would cancel. And there's no point dividing anything 0 by anything. It'll be 0 itself. So I'm not going to write it. Even if you write it, it'll be 0. Let me write it. And this still will be 0 itself over here. Okay, this part. Now what next? We have P here. So I'll take this P to the other side. So it's going to be V prime of T divided by V prime of T times V is equal to minus P. See, look, this is only P remaining because this is cancelled off and it's 0. When it moves to the other side, it'll be minus P. And then let's take V to the other side. P prime of T divided by V prime of T is equal to minus P divided by V. But look at the question. They have asked us minus C by V squared. What we do is look at the given equation. Let's rearrange and see what is P, because there's no P involved at the right side. So P is equal to C divided by V, isn't it? So I'll just substitute that over here. Minus remains P is C by V, and we already have a V at the bottom, so it's going to be 2 V's. Or it'll be minus C by V squared. Now look at this. Yes, that's the correct answer. The second question is to solve for P as a function of V. Okay, this given question now we should not do this implicit differentiation. What was this exactly with respect to time, right? dp by dt. This is implicit, and then we add dv by dt. That is prime v prime or p prime. This was implicit differentiation, but now we are doing derivation with respect to v, the other term. Treating v as an independent variable, compute v prime of v, compare p prime of v, and this particular equation. Okay, so I'll just clear this all off. And now let me solve the second part. The given equation is PV is equal to C. What I'll do is I'll just take it to the other side. So it'll be P is equal to C by V. And now let me derive both the sides. Here on the left side, it's going to be P prime with respect to volume. So that is V. And over here, we are deriving with respect to V. So imagine if it was Cx, or constant 2x, 2 by x. We'll write minus 2 by x squared, isn't it? Because when we bring this up, it'll be minus 1, then minus comes down, and x power minus 2, we take it down. Same way, I'll directly write minus c by v power 2. Okay, did we finish it? Yeah, we have done derivation. And then you do not need to write dv by dv, because we're doing with respect to v, it's 1. So we don't need to write that at all. So here, that will be the answer. And let's look at the question. We have to compare with part A. They are the same thing. Can you see that? They are same. So that is what it says. So P prime of t divided by V prime of t was equal to minus C by V squared. And the same thing is obtained when we derive the given equation with respect to volume as well. So as you can see, that's the thing. It's the same. The next question is about a real world problem here, but there's no figure given. So let's draw a figure. A dock is 6 feet above water. Suppose you stand on the edge of a dock and pull a rope attached to a boat at a constant rate of 2 feet per second. So there is water here, this is the ocean. There's a dock. Imagine this is the dock. And we are at the edge of the dock, somewhere over here. And we are pulling a boat. So imagine it's something like this. You're pulling this boat over here. The boat is something like this. Just imagine that's a boat. Some things, and yeah. And now, what did they give us? They have told pull a rope attached to it at the rate. See, this is being pulled. Imagine this is the rope. We can take it as R. The rate is given. See, feet per second. R is this. What about this? This is the x value, the horizontal distance. Let's take it as x. And this height is told as 6 feet. They've mentioned it. It's 6 feet. And over here, this is being pulled. The boat is being pulled. This is a very bad way of drawing a boat. But anyways, and assume that the boat remains at water level. So this is going to be at the water level over here itself. I mean, it's going to move, but it's going to be at the water level. At what speed is the boat approaching the dock when it is 20 feet from the dock? So this x value has been told to be 20 feet. And also another question, 10 feet from the dock, somewhere over here, when it reaches, what will happen? Isn't it surprising that the boat speed is not constant? Let's solve it and then we will check it out. So here we have Pythagoras theorem. Because this is 90 degrees, we can use Pythagoras theorem here. That's going to be r squared is equal to 6 squared plus x squared. Now what we exactly want, we have been given the constant rate over here. We have been given dr by dt with respect to time, because feet per second, so it should be divided by time. That is given as 2, but it's pulled, it's coming towards the left side, so it's minus 2 feet per second. That is given. And they have also given us the x values. So x values at 20 feet, 20 and 10. X is equal to 20 and 10. Now let's derive here both the sides. It's going to be 2 times r times dr by dt with respect to time. That is equal to the differentiation of any number. 6 squared is 36, but it's going to be 0 when you derive it. 0 plus 2x times, not again 2x, it's 2x times x dx by dt. Now we have this information. What do they want exactly? They want us to know at what speed the boat is approaching when the dock is. So this is what they want, the rate of change of the left, the distance, that's speed. So here we have 2r into dr by dt, isn't it? So let's substitute what we know. But before that, let's simplify how much we can. See, this 2 and 2 is 0, so it's 2r dr by dt, that is equal to 2x dx by dt. This cancels off. Now what about r? What is the value of r? Look, we know x value, that is 20, but we don't know r at all. You can find r by substituting the x value, but better than that, how about we write this r in terms of x and this value? So it's already written over here. So what is r? R will be equal to square root of 36 plus x squared. So I'm going to write that over here. Square root 36 plus x squared dr by dt, that is equal to, now here x, I'll take it to the other side. I'll write it as divided by x is equal to dx by dt. So this is what we had to solve. Now just solve for two cases at x is equal to say 20, and you should solve it at x is equal to 10. We can just use our calculators and do it. Let me show you. Let's write this equation out. It's square root 36 plus x squared divided by x. And here, why I wrote this? Because we have two values to check, right? What is dr times dr by dt? It is times minus 2. I had to write this. I've forgotten to write it. Let me just change. Let me write it below. It's square root 36 plus x squared divided by x. Dr by dt is minus 2. That is equal to dx by dt. That's basically x prime of t, and r by dt would be r prime of t. Now here calculate this firstly at 20. So what's the answer? It's minus 0.208. What's the next answer? Calculating at 10. Shift and so. See, this is bigger. And it makes sense. It's 10, right? See, as the boat is moving, initially, if there is some rate of change and it's going closer and closer, more it increases the speed. It increases the rate of change in the horizontal axis. That's the reason. So yeah, these two were the answers. It's negative because it's coming closer. See, this boat is moving towards the dock. And here we are getting at 20, x is minus 2.088, and here minus 2.332. The next question is another real world problem. Here the sand is poured into a conical pipe with the height of the pile equaling the diameter of the pile. What this means is height is equal to diameter. If the sand is poured at a constant rate of 5 meter cube per second, meter cube, it's volume, by second, it's derivative of the volume with respect to time, not second, sorry, not ds, it's dt with respect to time. Or you can write v prime with respect to time. That is 5 meter cube per second. At what rate is the height of the pile increasing? At what rate the height, that is dh by dt, as you know, you keep on pouring the sand in a conical. Imagine this is the cone. You're pouring the sand at this particular rate, 5 meter cube per second. You know, the sand is being a pile. It's increasing in radius. It's increasing in the height as well. So what rate will the height, the rate of change of height of the pile increase when the height is already 2 meters, when it reaches 2 meters? H is 2. Now let's see which formula to use. We have to use volume of a cone because they've told clearly a conical pipe. So V is equal to 1/3. Cone is always 1/3 pi r h squared. But here they have told, sorry, it's not h squared, r squared h, I believe. So it's 1/3 pi r squared. Yeah, that's the formula. H is not squared. I was just confused. Okay, so now here, do we have RH? No, but we have a relationship of H is equal to D. That means H is equal to 2 times R. Why do we write this? Because diameter is 2 times radius, isn't it? Now let us write R in terms of H because we need H, not R. So I'll try to remove this R altogether. So I'll take this 2 to the other side. It'll be H by 2 is equal to the radius. So the radius is half the height. Let's substitute everything over here. V is equal to 1 by 3 pi. R is basically H by 2 squared by H. Now let's square this up. It'll be 1/3 pi H squared by 4H volume. Now I will simplify this. 3 times 4 is 12. 1 by 12 pi. So I'll write pi by 12. H times H squared times H is H cubed. So this is the reduced form of the equation. Now what I do, I have to just derive both the sides. Implicit differentiation, what we have done before. So it'll be dv by dt. Here it is just v dash, that's it, nothing else, is equal to pi by 12. This is constant, but here when you derive it will be 3h squared multiplied by dh by dt. So this is the derivation, implicit differentiation with respect to time. Now what do we know? We have to find what is the rate of change of height, that is dh by dt at 2 meters, and we know what is dv also. So phi is equal to pi by 12 times 3 into 2 the whole square into dh by dt is unknown. So just put this in the calculator and you can solve it up. We'll just take it to the other sides. Simplify how much you can. Here it is, how much is this? It's 2 squared, 4 times 3 is 12, and this cancels off with this. So just pi goes to the other side. So dh by dt will be equal to phi divided by pi. You can just put that in the calculator and you'll get the final answer. So it's phi divided by pi. Just press equal to, or if it is in fraction again, just press shift SD, sorry, not shift, SD, you'll get the answer. It's 1.59. Now that is in terms of meter per second, is equal to 1.59 meter per second. That is the rate of change of height with respect to time. So let's just look into the answer. Here they have just written in phi by pi. That is absolutely fine. We can even put in the calculator and find this value as well. So it is pretty simple. I remember 2 years ago this had come for the final exam, during the exam for the grade 12. So what we need to do over here is first write the conical, it's conical shape. So cone's volume is given by V is equal to 1/3 pi r square h. You need to remember the formula because it's not given here. And then we just do the substitutions. What is known? R is equal to h by 2 and then square it up and you rearrange the term. It will be V is equal to pi by 12 h cube. You do implicit differentiation with respect to the time. It will be dv by dt. Here it's going to be 3 times h square and dh by dt. Then all you do is substitute what is known. We know dv by dt. We know h is 2 given in the question. And then we can just put in the calculator and get the answer. Let's look at the next problem. This problem is a very huge problem. Let us see what is exactly required. Over here at the last thing they have told, find f derivative of t. For this function we have to just derive. They have given you what are the terms. So I'm not going to read it. You can pause the video and read it entirely. It's about a guitarist and the frequency depends on the L, that is the effective length in the guitar, and square root of T, that is tension, divided by rho. This is called as rho, the symbol. It's usually used for density. Now what we do is we will write the given function 1 by 2 L square root T by rho. Let's substitute what is known. They have told suppose L is half. So here 1 by 2 times half. So this cancels off. And what is this square root of T by rho? That entire thing is 220 multiplied by 220. So what is the frequency? This is 1. 1 times 220 is 220 itself. 220 hertz is the frequency. Frequency is given by hertz. Cycles per second. Now this is just f value. What is the derivative? Let's do the derivative. F derivative would be, now let us keep the same thing before that. Before doing the derivative, let me write f is equal to 1 by 2 L square root t by rho. Here, look carefully. They have given us L dash. So what I'll do is I'll just substitute this one. I'm not going to substitute L because I need to find L dash, isn't it? So what is this value here? Because I do not know these values over here. So 1 by 2L times 220. And this cancels off. One time it's 110. So F is equal to 110 by L. So how can I derive? Just derive with respect to this time, f prime of t. That means df by dt is equal to this one, 100. 100 is a constant. What is the derivative of 1 by x? Do we minus 1 by x squared, right? But since we are doing implicitly, then we have to write x prime as well. Again, whatever is there with respect to whatever we are doing. So it's a 110, but it'll be minus divided by L squared. How we do it is this goes up, it'll be negative power, and this is how we solve that. But don't forget dl by dt. Now then we can substitute what is known. What exactly do we know? We know the L value, we know the dl by dt value is minus 4. So let's substitute everything. Minus 110 divided by this half, the whole squared, multiplied by minus 4. That is the derivative that is given as f prime of t with respect to time. Okay, let's put this in the calculator and check what will be the answer. All you need to do is substitute this. Let's use the fraction. Minus 110 divided by, use the brackets, it's 1 by 2, 1 divided by 2, or you can write 0.5 if it's easier. Square it up, multiplied with minus 4. You can use bracket whenever there is minus sign. So I'll just use the brackets here. So that's the answer. It's 1760. You can see here the answer must be 1760 cycles. That's the derivative, cycles per second. Now here they have also told at what rate will it take to rise the pitch 1 octave, that's double it off. Here what they do is, all you need to do is the cycles divided by this. So all you do is f of t divided by f prime of t, and you would get 220 divided by 1760, that'll be 1/8. Now what happens here? It's cycle per second, and this is cycles. All right, cycle per second. This is cycle per second because we're deriving. It's cycle per second squared. Sorry, not squared, per second. So this cancels and this goes up, so it'll be 1/8 of a second because it's in the denominator's denominator. It'll go up, so that'll be the answer. We'll move on to the next problem. Suppose that you're blowing up a balloon by adding air at the rate of 1 feet cube per second. If the balloon maintains a spherical shape, sphere this is, the volume of the radius are related by, volume is equal to 4 by 3 pi r cube. This is the sphere formula. Compare the rate at which the radius is changing at these two radiuses 0.01 and 0.1 feet. Discuss how this matches the experience of a person blowing up a balloon. We have been told the formula. Let's use this formula. Volume is given as 4 by 3 pi r cubed. All we have to do is we need to derive it. There's only volume and there's radius. They have told the rate at which adding the air. Adding air is in the sense volume. This is rate of change of volume because feet cube is volume. So that is dV by dt with respect to time. What we need is the rate of change of radius changing. dr by dt is required. So I'm going to just derive this dV by dt. That is equal to 4 by 3 pi. 4 pi by 3. I just write it like this. What happens here? 3 times r squared times dr by dt. Because it's implicit differentiation. Now then, what is dV by dt? It's 1 is equal to 4 pi by 3. And this, I just simplify here. 3 cancels. 4 pi r squared and dr by dt. We need to find dr by dt, so I'll leave this over here and everything to the other side. So 1 divided by 4 pi r squared is equal to dr by dt. Now then, what is the radius given? First case, at r is equal to 0.01, what happens is dr, the rate of change of radius with respect to time, that is also given as r prime with respect to time, can be written as 1 by 4 pi r square, right? I'll write it as 0.01 the whole square. You can directly find it over here. And the second case, the first case, the second case at 0 r equals 0.1. What happens here? It's in terms of feet, so it'll be feet per second here. Whatever the answer is there, it'll be feet per second. Remember, the units are important and it's writing exam, so please make sure you write the units. Here it's dr by dt, or we can also write it as r prime of t, that is equal to 1 divided by 4 pi. This is constant, but what is r? It's 0.1 squared. So remember, it's 0.1 squared. Don't forget the square. As it is over here, whatever we written, r values are given. There are two different r values. So what is that? It will also be in terms of feet per second. You just put these values in the calculator and you can find it out. Here we have 1 divided by 4 pi is by shift and the symbol here into 0. I'll just use the brackets, 0.01, close the bracket and then square it up. Here you can see it's 795.77. The rate of change is very much high, you can say. It's a huge value, isn't it? So here it's 795.77 feet per second. What about the next case? Only it is, remove the 0 off, and it's 7.95 or 7.96 feet per second square. Why is there so much difference? Look, when you initially blow air into the balloon, it's just a small balloon, right? It'll be big very easily, very quickly it'll gain the radius. So the rate of change of radius when the initial radius is such a small thing is more, it's always high. But as you go bigger and bigger, the rate of change of radius is low because it has already taken much volume. So if you practically think about it, when a balloon is so small, when you just blow maybe 1 or 2 times, it'll become so big. But then if you just put 1 or 2 times, it'll just increase a little bit. So that's why as the balloon gets bigger, the rate of change of volume, rate of change of radius reduces, and that is what has been visible. That is the explanation. So you can just write over here, discuss how this matches with the experience of a person blowing up the balloon. I'll just write it out. When the balloon is smaller, the rate of change of, I'll just write dr by dt, that is rate of change of radius with respect to time, increases greatly, whereas when the radius increases, the rate of change dr by dt increases steadily or slowly, you can write steadily. This is just to tell what you have understood, just imagine you're blowing a balloon and then you will understand it. So that's the answers. Over here they have written in terms of pi. That's absolutely fine. But it's better to write it in terms of decimal so you'll understand what are the values exactly, and then you can tell it. See, at first radius expands rapidly, later it expands more slowly. Absolutely, that's the same thing, what I told. Now we have a very interesting problem. Water is being pumped into a spherical tank of radius 60 feet at a constant rate given over here. So radius r is given and constant rate is given, that is dv by dt. Find the rate at which the radius of the top level of water tank changes when the tank is half full. So now this is a sphere. Water is being pumped into this. Imagine the water is filled so much. Okay. What is the height? From the center, this will be the height. Not from the center of the sphere. The center of the sphere, this is the radius. This is the radius, right? This height is considered. Now what about this one here? This half of this is basically the radius of the water level. You can take anything. You can take it as X, A, B, C, anything. So this is the given thing. It's a sphere and the water is filled in this. They call this a spherical cap. Whenever we have such case where a sphere is there and water is being filled, and they have told regarding the water radius of the water level, it's not just the sphere formula. It's not what we just used. Let me just show you over here. This is the figure. It is a spherical cap which we need to realize. The formula of the spherical cap is given as here. V equals, it's pi r. See, how I remember is V is equal to pi r h squared minus pi by 3 h cubed. It is a simplified form. Otherwise, the pi is written out and 3 is written out and you will have 3r. It's a little bit complicated. This is more easier for me to understand, so I just use this formula. Now, what is given over here? This is the volume, which is pretty simple. R is basically the radius of the sphere. The radius of the sphere, not the volume or anything. Not the circle formed by the volume, it's of the sphere. H is the height of the water level. How much ever the water is increased, that's the height. Now here, A, which I've considered here, is the radius of the water surface. Now, what exactly do we want? The rate at which the radius of the top level of the water in the tank changes. So it's basically this radius. I'm not going to write R because we already know the radius of the sphere is R. So A is considered. We need A, dA by dt. Or you can consider this to be X. Absolutely fine. Up to you. That rate change with respect to time is required. And they have also told when the tank is half full, that means it must be exactly half full. When the tank is half full means H is equal to how much? Is equal to the radius of the sphere, isn't it? Is equal to the radius of the sphere. And you can go ahead as well. If it's half full, even this is going to be equal to the radius of the water. That all is given as 60 feet. So this is the concept. Why? Because imagine this is the sphere, it's half full. So that's the radius, this is the radius of the sphere itself. So that is why they all these H, radius of the sphere, and A will be equal. Now how would we solve this? Here we have R, that's the radius of the sphere. We cannot do implicit differentiation with volume, with height and radius. So this is given. Let's substitute and simplify. Volume will be equal to pi times 60. So I'll write it as 60 pi. The constants first. 60 pi h squared minus pi by 3 h cubed. Let me do implicit differentiation over here. It will be dv with respect to time, that is equal to 60 pi times 2h times, don't forget there is dh by dt, minus pi by 3 times 3 h squared dh by dt. Now let's simplify how much we can. dv by dt is equal to 60 times 2 is 120 pi h dh by dt. That minus, this cancels off 3 and 3, so you have pi h squared dh by dt. So what can we find from here? We need dA by dt, but we are getting the rate of change of height. So if we know the rate of change of height, that is important to us. Why? Because look here, I can use Pythagoras theorem and I can relate A and H and radius. So let us find this dH by dt, because there is no other thing which we can solve from here. We can't directly apply the radius of the water. A cannot be applied. So we will solve this. Now dH by dt is there, that can be removed common out, and all the terms here I'll just remove take it to the other side. But before that, let me substitute the values, it'll be easier. dv by dt, where is it? This is the dv by dt given, that's 10, that is equal to 120 pi. What is h? H is 60, because h, the height, must be half when the tank is half full. That means it's the radius of the sphere. So this is again 60 dH by dt minus pi into 60 squared dH by dt. I'm just going to take dH by dt, both of this common outside, and whatever is there, we can take it to the denominator. So it's 120 pi times 60 minus pi times 60 squared. Why? Because I've removed these two common outside. You can take it left side or right side, it's the same. dH by dt. Now this entire thing goes down here. 10 divided by 120. So you can just simplify these. So what is 120 times 6? It'll be, I'll just use the calculator here. Here we will just multiply 120 times 60, that is 7,200. And here we have 60 squared, that is 3,600. So 7,200 pi minus 3,600 pi is equal to dH by dt. What happens here? 7,200 minus 3,600 is 10 divided by 3,600 pi. So we'll cancel one of this 0. You will get 1 divided by 360 pi. So this is not the final answer. This is the rate of change of the height with respect to the time. So this is very important. This is basically the first step. I hope this much is clear. 1 by 360 pi gives you the rate of change of the height with respect to the time. How would we find this rate of change of the radius of the surface of the water? Now, if you look carefully, this is the Pythagoras theorem. We can relate it by Pythagoras theorem. This is the hypotenuse r. We have r minus h. See, wherever the height is there, the total will be the radius minus the height. So that's the simple equation which we can relate it. I'm going to erase this. I'm going to remove this all. So please note down these steps. You can pause the video now and you can go through it if you want to go through it again. Now, what is the relationship here? It'll be r squared equals a squared plus r minus h the whole squared. Okay. What do? We'll just use the squared formula. It'll be r squared is equal to a squared plus r squared. Now this is a minus b the whole squared identity. It's a squared minus 2 times ab plus b squared. So r squared minus 2 times rh plus h squared. And now apply what is known. But before that, let's simplify. See, this r squared, when it goes to the other side, becomes minus and goes off. And I will take this, r and h, everything to the other side. So it'll be 2rh minus h squared is equal to a squared. I'm not going to take h to the other side outside because it's just going to be more complicated. But what about r value? Radius is 60, isn't it? So it'll be 2 times 60 h minus h squared is equal to a squared. It'll be 120 h minus h squared, that is equal to a squared. Now I have constants and I can just apply the differentiation with respect to time. It'll be 120 dH by dt minus, this is 2h times dH by dt, that is equal to a squared will be over here. Let me just remove this. It'll be 2 times a into dA by dt. Now what is dH by dt? We just did it, right? 1 by 360 pi. So over here I'm going to type out, this is 1 by 360 pi minus 2. What is h now? It's half, isn't it? This is basically at when the tank is half full. That means Height will be equal to the radius, so that's going to be 60 over here. Multiplied by, what is dh by dt? It's going to be 1 by 360 pi. That is equal to 2 times 2a dA by dt. Now let's solve this up. Here we have to find dA by dt. 120. Look at this. This is 60 times 2. It's going to be 120 itself. So these both will cancel. It's 120 times 161 by 360 pi minus 60 times 2 is 120. It's 0 here. So I'll just write it out over here. It'll be 0 is equal to 2a. A is also 60 basically. Okay. Why? Because at the when the tank is half full, the A will be also half the radius. The radius of the water will be equal to radius. It's 60 dA by dt. Or even if you don't substitute, if you just take it to the other side, anything divided by 0 will be 0 itself. This is 0. This goes to the other side, will be 0 divided by 120. It's 0 is equal to dA by dt. And let's analyze this. Is this correct? Say the sphere is there. As you keep on going up, it will increase. The rate of change of the height with respect to time increases. It keeps on increasing, but the radius also increases. And the sphere is such that it will be at the center, it will reach its maximum radius, the surface of the water, maximum. But what happens as we go ahead? It will start reducing. Why? Because a sphere is such that it will start reducing. Only at this middle point, if you look carefully, the exact sphere, the middle point, this is maximum. But from here it was increasing, and now this is the midpoint, and then it'll start decreasing. So the derivative at that point, this is the slope, it goes like this and like this. It start decreasing, right? The derivative is 0. And yes, that is true, which we got 0 is correct answer. That is why they have told half full. At half full, it doesn't change. The derivative rate of change of the surface of the water with respect to time must be 0, because after that instant, just after this instant, when it is 61, the height, it starts reducing. This starts reducing the rate of change of the radius, because it is getting smaller and smaller. Only at half, it's the maximum, and therefore the derivative is 0. So this is the way we solve the first problem. So we had got 1 by 360 and then 0. So you can see the solutions. These are the formulas which we use. And over here, we have got the first dH by dt, that is the rate of change of height with respect to time, as 1 by 360 pi feet per second. Then we can use this value and solve the dA by dt. So now here, they have just rearranged it differently and solved it. You can follow my method, whatever I've done. The answer will be the same. The answer will be 0. You can see over here as well, dA by dt. Finally, when you solve it up, it will be 0 by 60 multiplied by this term. It's 0 itself. Now they have one more part, that's part B. Find the height at which the height of the water in the tank changes at the same rate as the radius. So what they're asking is, the rate of change of the height with respect to time must be equal to the rate of change of the radius, that is dA by dt. When I was trying to solve this by myself, I used Pythagoras theorem and it didn't work. But when I take the height, it'll work. So let me show you how to solve this. What is the radius? Radius is equal to, now imagine this one. Imagine the water is anyway below the radius. We don't exactly know where is the water, right? But we should know wherever the radius and the radius of the water and the height is changing at the same rate. So if that should happen, it must be less than this. Why? Because the height is increasing here. The height keeps on increasing. Now, if you practically think, no matter what, the height will keep on increasing as we go up and up and up. But after the radius, after if it's half full, when the radius is increasing, when the height is increasing, will the radius increase? No, it will become smaller and smaller as the sphere becomes enclosed, right? This will be smaller. So it can't be more than this. It should be less than that. So it should be less than half of the radius. So here, radius If that's the radius, and height must be less than that somewhere over here. So the total radius minus h will give you this part. So what I'll do is the radius is equal to h plus r minus h. Now this is not going to help me because if I just substitute this, the r cancels, h cancels, it's an identity. But what I can do is instead of r and h, I know from the Pythagoras theorem, r square is equal to a square plus r minus h the whole square, isn't it? So what is r minus h? Let me just take this a square to the other side. R square minus a square is equal to r minus h the whole square. Take the square root on all the sides. So it will be square root of r square minus a square is equal to r minus h. So I can substitute this over here. Why do we do that is because we need dA by dt that is equal to dH by dt. So that is the condition for us given over here. Now then what I'll do is R is equal to H plus square root R square minus A squared. When we derive over here, let's derive both the sides with respect to time. We will get dr by dt is equal to dH by dt. And then what about this? Here we have a that is a variable. Though this r is a constant, we have to derive it. So this is going to be 1 by, see what is this? It's half, power half. When we derive half, it will be 1 by 2 times this negative half, and then we take it down. I'll just use the identity. Root x will be equal to 1 by 2 root x. I hope you remember this. I'm just going to use the identity. It'll be r squared minus a squared here. And it's not over the chain rule. Whatever is inside also we have to derive it. What is inside? It's dr by dt. And not dr by dt. We have to derive it properly. This will be 2r times r prime of t. I'm just going to write it. And minus, it will be minus 2a times a prime of t. That is dA by dt. Okay. So that is what's happened. I'll just erase this part up over here because it might be confusing otherwise. So here we go. This is what we have. Now what happens with dr by dt? What exactly is this dr by dt? It is a constant. R is a radius. It doesn't change. It's 60 feet. So this is 0. Derivative of a constant is 0. dH, yes, rate of height is changing with respect to time. This is correct. Let it be dH by dt. What about this? Plus, we have 1 by 2 square root r square minus a square. This entire thing is multiplied with what? Here, this will be, okay, this is again a bracket which I forgot, right? Once we have derived the square root, then whatever is the chain rule is inside a bracket. Now here, this dr, we don't, r is 60, it'll be 2 times, it'll be 120, but the derivative of the radius, constant radius of the sphere is 0. So it's 0 minus 2 times a prime of t, or dA by dH. I'll just, you can write anything anyways. So this is the situation. So now this is 0, this is 0. So let me rewrite it, dH by dt plus, what have we got over here? We'll just multiply this, so this cancels off, and what remains is, it is a prime of t divided by square root r square minus a square. I hope this much is clear. So what exactly we want? We know that dH by dt is equal to dA by dt, isn't it? So let me take this to the other side. Okay, this one to the other side. It's a bit clumsy now. It'll be minus. Now this, okay, wait a minute. Now we have a minus over here, isn't it? We already have a minus over here. So when we multiply, it's going to be minus. So I'll just, this is not plus. I forgot to write the minus sign. I'll just remove that to the other side. I'm going to take this to the other side. It's going to be positive. So it's going to be a divided by square root r square minus a square. What is this? dA by dH, dA by dt, not h. So here will be equal to dH by dt is equal to dA by dt. So I'm just going to write the same thing because dH by dt and dA by dt are equal. That is what we are solving for, when both the rates are equal. So here let me cancel them off. So what happened? I've got now a, I'll take this to the other side. It's 1 is remaining, so I'll move this to the other side. A is equal to square root r square minus a squared. So here now I'll square on both these sides. It's going to be a squared is equal to r squared minus a squared. Let me take this minus a to the other side. It's going to be a squared plus a squared. It's 2a squared is equal to r squared, or I'll divide both the sides by 2. So I need to rewrite this somewhere over here. I'll just write it. So it's going to be a squared equals r squared by 2. Let me take square root on both the sides. A will be equal to square root of r squared and square root of 2. When we take the square root of r squared, it's just going to be r divided by root 2. So this is the simplification. We found the a value when the rate of change of height and the rate of change of radius are equal. We will get r by root 2. Okay, but what do we exactly want? We need to find the height. That's not the a value, the h value we need to find. That is fine. We can easily find it out because we have over here, see, for example, here we have this equation. This equation can be used, or yeah, this only equation can be used because we know all, or we can use one of these equations as well. So what I'm going to do is I'm just going to use this equation and I will find h value. I can just take this to the other side and solve it up. I hope this much is clear. I will now clear all this. You can pause the video and go through it if you want to. So again, how to get that equation? It was r is equal to h plus r minus h. But we know from Pythagoras theorem, r minus h is, here it will become square root r squared minus a squared. Now, I can move this to the other side because I want to find only h, right? R minus square root r squared minus a squared is equal to h. Now I will substitute the a value which we had recently got. So r is equal to square root r squared minus, what was the a value we obtained? It was r divided by root 2, the whole square now. That is equal to h. So let me simplify this. R is equal to r squared remains minus, let's square both. The top one will be r squared divided by root 2 squared will be 2. So it will be r squared by 2. That is h. Now imagine this is r squared is 1 and it will be 1 by 2. What will be x minus x by 2? What is 1 minus half? It's half, right? Even x minus x by 2 is x by 2 itself, half of x. Same way we can write over here, this is r squared minus r squared by 2 will be r squared divided by 2. That is h. Okay, I have done a mistake. For some reason I have made it all equal to here. It's minus. So my bad, this r was minus. I changed it over here by mistakenly and then I forgot. It's minus. R is minus. This is all minus. R minus. Over here we have equals h. So now what? Here let's use the square root. The above term will be r and below term will be root 2. So again, r minus, not equal to, it's minus r divided by root 2 will be equal to h. Or we can remove the r outside as common. So it's going to be h will be equal to r into 1 minus 1 by root 2. So this is the answer for h, but we know the radius, right? What is it? 60. So just substitute it. So 60 times 1 minus 1 by root 2 must be equal to the height. So at that particular height, we will have the rate of change of the height of the water and the rate of change of the radius of the water equal. So we used all this, a value, we got the a value in terms of radius. So now we could solve it. Now everything is in terms of radius, and just put this in the calculator. Here then we have 60 times 1 minus 1 by square root 2. So close the brackets, and here we go. The answer is 17.57 feet. Or you can leave it like this in terms of feet, because everything was in feet. So that is the final answer. When the height of the water is 17.57 feet, you can have the rate of change of the radius of the water and the rate of change of height equal. And it makes sense. Why? Because when you come to the half, it's not at all possible. The rate of change will be 0 over here, and h will always be increasing. It's not possible more than 60 or above. It should be less than 60. Yeah, it's about right. The 17.57 fits the description. So that is the final answer. I'll just put it back. I hope that's clear. If you have any doubts, please look at these steps. You can write them down. The answer is 17.57 feet. It's been a lengthy problem. I hope this doesn't come for your exam, but this is how we solve this. So we can, okay, the steps are over here. You can just go through these. But whatever I solved is more, okay, they have used some other method altogether. So I would suggest you to stick to the method which I did, because it's much easier to understand and solve. And here the answer will be the same, I believe. So they have used a very tough method. And yeah, that's what we had got. It's 17.58. That's okay. It's almost the same. We move to the last problem in this question. Sand is dumped such that the shape of the sand pile remains a cone. Again, we have a cone shape. Okay. With the width height equal to twice the radius. So here they have told h is equal to 2 times r. If the sand is dumped at a constant rate of 20 feet cube per second, it's dv by dt. Find the rate at which the radius is increasing when the height reaches 6 feet. H is 6. Okay, we know the formula for this, right? Volume of a cone is 1/3 pi r squared h. There is r squared and h. Whereas for the cone, it will just be r cubed. There is no h involved. So how do we solve this? First, substitute what is known. Height is equal to 2 times the radius. So you here, first of all, what is required is, if the sand is dumped, find the rate at which the radius is increasing. So we need the dr by dt. So I'm going to remove this h and make it in terms of r. 1/3 pi r square. H is 2 times r. Let me rewrite this. It'll be 2 pi by 3. R square times r will be r cubed. Let me derive both the sides with respect to time. Here there's only one term, so it's only v, so it'll be dv by dt. Here it's going to be 2 pi by 3 r cubed. When you derive, it will be 3r squared times dr by dt. This is what we need to solve. But the problem is the height is given as 6 feet, not the radius. So what is r value? Now we'll use this relation. H is equal to 2r. So what is r exactly? It will be h by 2 is equal to r. Let's substitute the 6 feet. So when h is 6 feet, r will be equal to 3. So can I use this 3? Absolutely, I can use this as 3 squared. Let's cancel this off. And dv by dt. Okay, what is dv by dt? I'm going to substitute this value as well. It is 20, that is equal to 2 pi r squared. R is 3, so it will be 9. When you put over here 3 squared, let me write it as 3 squared itself, times dr by dt. So take all these values to the other side and just solve it up. It will be 20 divided by 3 squared is 9. 9 times 2 is 18, so it will be 18 pi. That is equal to the rate of change of radius with respect to time. Just put that in the calculator and you will get the answer. Here we have 20 divided by 18 pi. So the rate of change of radius is 0.35. And here we go. Now they have just written in terms of pi, okay, but they have simplified it. Now wait a minute, they have found out dh and d. You do not need to find dh because they have just told find the rate of change of radius, okay, when the height reaches. You just have to find dr. You don't have to find dh by dt and dr by dt. This is 18. So this can be simplified. Two table goes. It'll be 10 by 9 pi. That's the answer. You can see dr by dt will be 10 by 9. That's what we also got. There is a part B of the problem. Let's look at this. Repeat for sand pile for which the edge of the sand pile forms an angle of 45 degree with the horizontal. Now the same question must be repeated. Okay, let's do it again. Let's see what's the figure. It's the cone, and here they have told the, as the sand is being dumped, it's increasing and all that, right? The angle is 45. So here, what happens when it's 45 degrees? Imagine this is the height, this is the radius, right? 90 degree. When you have 45 degrees, this values, they both are equal. Okay, these two values are equal in the sense, if you have, I'll show you in the calculator why it's equal. If you have these two sides, say 3 and 3. So what is tan theta? Tan theta is opposite by adjacent, right? Hypotenuse is not involved. Tan inverse of the same thing. So 3 and 3 is equal to 45 degrees. So that's the reason, Or if you just multiply tan 45 by any of the side, you're going to get the same side. They are equal. So 45 degree means these both are equal here. So that's the thing. So if they both are equal, that is radius and the height is equal. So dr by dt must be equal to dh by dt. So the rates are also equal. That is what it says. Now then we will solve it up. We will use the volume. Volume is 1 by 3 pi r square h. But now I can use it in terms of r or h only. What I'll do over here is 1 by 3 pi, instead of r and h, I'm just going to use r cube. Now let me derive both the sides. So why? Because we have to find the radius. Repeat the same problem, right? We have to find the rate of change of radius. So I'm using r. It'll be dv by dt, that is equal to 1/3 pi 3r squared times, here we have dr by dt. And now this 3 and 3 cancels off. Now if you look over here, what is the r value exactly? The radius is not given, but the height is given. Height is 6 feet, and now here we have this new condition. The old condition is gone. It's not equal to twice the radius. Here if h is 6, that is r or h, both of them. So we will just substitute the values here. The rate was 20, not 10. I'm sorry, it's 20 over here. They've given over here the rate of change of volume basically. That is equal to pi, r square is 6 squared, and then we have dr by dt. So let's take this to the other side. It will be 20 divided by pi times, what is 6 squared? It's 36. That is dr by dt. So you can put this in the calculator and simplify, but the 4 table goes. So I'm just going to do 4 5 times is 20, and over here 4 9 times. So 5 by 9 pi is equal to the rate of change of radius with respect to time, or the rate of change of height with respect to time, because both of them are equal. So it should be 5 by 9 pi. So that's the correct answer. So this is the exact method. It's better to do these methods because over here in the solution sets, the methods are not exactly mentioned. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. The question 18 is about the properties of definite integrals from lesson 5.4. Here we have been given definite integrals. Definite integrals are the integrals when you have numbers over here. An integral limits are given 1 to 3, 1 to 3 and so on. But these are not just finding definite integral of an equation. It is of the function f of x and g of x, provided the function values are given. So how do we solve them? So first, what happens is this integral is multiplied here inside to both the terms and even the d of x. It's distributive property. So what happens over here is integral from 1 to 3 f of x dx. Oh, it's plus integral from 1 to 3 g of x dx. I'm sorry, I've written this outside. It should exactly be inside, it's inside down, or you can just write below it, Sometimes we write below it and above it, but it's actually, at the base right, base right. Now, what we do is we look into the question. They have told for this exercise 37 and 38, assume these values. Integral from 1 to 3 f of x dx is 3. So this part is becoming 3 here. Plus, what about the second part? It is negative 2 minus 2 here. So 3 minus 2 is 1. That's the answer. What about this one? Same method, same thing, but it's just that we have a coefficient here. When we multiply, the coefficient also remains, but it's minus this dx inside. So when you're writing, if you just write 1, 3, over here you can write 2 f of x minus, again, 1, 3 g of x. This is wrong. Why? Because this d of dx is very important term as well. Because it's in writing, please make sure you write it properly. And now substitute this 2. You can write it outside or over here, it's fine. It's better to write it outside because the values given to us is only integral from 1 to 3 f of x dx minus integral 1 to 3 g of x dx. So now what are the values? It's 2 times 3 because f of x dx is 3 minus, what is g of x? That's minus 2. So it's 6, minus and minus becomes plus 2. The answer is 8 here. So this is how we solve these pretty simple problems. First one is 1, 8. Please do try these by yourselves. You can pause the video now here, solve it, and then continue. I hope you tried by yourselves. Now again, it's the same thing. Multiply these over here. Integral 1 to 3 f of x minus integral 1 to 3 g of x. dx is there for both the terms. And the first value is 3 minus of minus 2. And here it will be 3 plus 2, that is 5. And for the last problem here, integral 1, 3. I can directly write 4 outside because that's the coefficient term. G of x dx minus 3 outside integral 1 to 3 f of x dx. Now what is g of x? It is given as minus 2. So now don't be confused. Don't think, okay, this was the first one. No, it's g of x, that's minus 2. Write it first. 4 outside, minus 3 times. What is f of x? It's 3. 4 times minus 2 is minus 8. Minus 3 times 3 is 9. 16 plus 1 is 17. Negative 17 is the answer. These are the answers. Minus 5 and minus 17. Please make sure you write these steps and then find the answers. The question 19 is to write the equation of a tangent line, and here the function is defined as a definite integral. This is from lesson 5.5. Here we have a function given to us, y equals integral x 0 to x, the limit, sine square root t square plus pi square dt, x is equal to 0. What do we do over here? First of all, let's see, the question is to find an equation for the tangent line. How do we write an equation of any line? The formula is like some similar to this. If you remember, m is equal to y2 minus y1, x2 minus x1. This is the slope formula, right? Just take this part to the left side, and from here we can rearrange and get the equation. Now here this is just written as y and y. This is generally written as naught. So y minus, I'll take it to the other side later. So m times x minus x naught plus, minus goes to the other side, becomes plus y naught. Now you can write this over here as well, minus y naught, that's up to you, but you can just write this in this form. Now what do we want? Y and m changes, x naught and y naught changes, y and x remains as it is, y equals to something, this is unknown, but x remains the same. minus, what is x naught value? Whatever is given over here in the question, that is it. That is 0, x naught plus this is unknown. There are two unknown terms. Now how can we find m and how can we find y naught? Y naught can be easily found out. This is the given equation, right? What does y naught mean? This x naught, x becomes x naught. If you take the limit from 0 to 0, see, definite integral from year to year, when it's the same limit, it's 0, right? Directly we can write y naught equals 0. Why? Because over here it's from 0 to 0. Or you can write, since it's the writing exam, just over here I'll write somewhere at the side, because under this I will write the derivation. Now over here I can just write y naught equals 0 to 0 sine square root, doesn't matter which variable it is, x squared, t squared. Over here we know it's 0 and 0, isn't it? So it's pi squared dt. This is equal to 0. So now I write the 0. I'll show you in the calculator as well. Here, let me take this symbol over here, integral, sorry, only once. Let me write any equation. Now, just for argument's sake, I'll just take x cubed plus 554x, just a random one, okay? Let me take it as x. Now here, let me start with 0 to 0. The answer is going to be 0. Why? Because when you apply the upper limit, there'll be 0 squared, so on, minus 0. It's the same limits you're subtracting. It not only is with zeros, but it can be any limit. Say 3 and up limit also is 3. It's 0. Let me go to, say, for example, minus 2. If you change, then yes, of course, it'll be different. But if you have the same limit, say minus 2, it should be 0. So here, when these matches, and all of your problem, this matches, so y naught is directly 0. Okay, the m is still missing. What do we do for m? Now here we need to derive this. Now derivation is dy by dx, right? So y dash with respect to x we are deriving, so y dash of x. What happens here? Now, you know derivative d by dx and its opposite, like inverse, is integral. So they basically cancel off, isn't it? So here, instead of doing all the derivation and then getting the same answer, when we derive this, this integral is gone off. And what is this variable over here? X, right? Instead of t, just write x squared plus pi squared. This is the answer. That's a derivation, no plus c or anything. So this is it. Now here, what do we want is, we need m at this point, x0. So over here, you need to substitute this value of 0 over here. So y dash of x is equal to sine square root 0 squared plus pi squared. Now it's basically sine pi. Over here 0 squared is 0 and square root of pi squared, this cancels, so you will have sine a pi, and that is equal to 0, isn't it? So basically y dash of x, that is m, the slope, or y dash of x, whichever terms are easy for you can write it out, because I prefer to write m for slope, because you know it's a simple thing that I always remember. Now you can write this m as y dash of x, that is the derivative, y prime. It's the same, the slope itself. And this is the answer, and that will be the final answer. 0, not final answer, 0 multiplied by anything is 0 and plus 0, so y is 0. So this is the equation. This is basically the equation for the tangent line. This is the derivative. So these are a few important things. Now here you can check this in the calculator as well. Let's see in the calculator. When we obtain this sine, I'm just going to write square root directly, x squared plus, now this pi is in radians. If you don't want to change this to radian, if it's in degree mode, then remember pi is equal to 180 degrees. So I have to write 180 degrees. What's the answer? Now what is x value? We need to calculate x value of 0. It's 0. Or you can just change this over here to 0 square. Okay, it's 0. Now I'll change this to pi square and I'll show you the mistake. This is wrong. Why? because this is in degree mode and pi is not set to 180 degrees. So you need to press shift, mode and 4 if you want to use pi, and now you'll get the answer 0. Okay, over here you can see. But the easier way would be, because only this requires the changing, instead of changing this to degree radian, if you just clear your calculator, the default is degree. So write sine square root, here it is 0 because x value is given as 0 square, plus instead of pi write 180 degrees, 180 degrees square, and the answer is 0. Here you go. So that's how we solve it up. Here it's written just in sentences, but it is highly preferable to write like this. Okay, this will fetch you full marks. I'll solve this problem and only the important things what are required for you to write in the exam will be mentioned. So first thing, when I see the tangent line, I need the slope. So y dash of x, that is equal to m, the slope will be equal to, I just remove this because derivative cancels off this integral. It will be natural logarithm of, what is the above term? X. So it will be x squared plus 2x plus 2, and that's it. Now let's find the slope at this given point. The given point is -1. So it's basically y dash of -1. That is the slope we want. Now here, what happens to x? It's -1, the whole square, plus 2 times -1 plus 2. Just put this all in the calculator and you will get the answer. Here you can see above, natural logarithm in the calculator is ln, this symbol. And then you can see it's -1. Open the bracket because -1 is there. If you just put -1 square without brackets, only 1 will be squared and -1 remains. So this is correct with the bracket, plus 2 times -1 plus 2. And the answer is 0. So here the slope is 0. M is equal to 0. It's not over yet. What else can we find? Y when x value. So I'll just write over here y naught. Okay. Here what happens? It'll be -1 to -1 itself. And what is the given equation? It is t squared plus 2t plus 2. Now if you apply the limits and everything, the same term minus the same term, you know, if you apply the limit, what happens? You're no need of integrating or anything. If you apply the limits, whatever is the value, the same thing will be subtracted because upper and the lower limits are same. It is 0 here. Now let's write the equation. The equation is y equals m of x minus x naught plus y naught. This is the equation you need to remember. Equation of any line. Now tangent line at this point also we can use the same thing. So y is equal to, what is m? 0 times x minus, what is x naught? The initial given value. See, just remember the given one is always x naught. This one. It is -1 plus, what is y naught? It's 0. So here I don't need to solve this x plus 1. No, why? Because x times anything is 0 times anything is 0. Plus 0, it's 0 again. This is the equation. So that will be the answer. You can see here that is the derivative and this is the equation here. I'll quickly solve this up. You can pause the video and solve these problems by yourselves because it's the same procedure now. Here y dash of x, that is equal to the slope, is equal to cosine pi x power 3, and y dash of 2, that is equal to the slope, will be equal to cosine pi multiplied by 2 to the power 3. We need to use a calculator here, and remember pi means 180 degrees. I will type in cosine, not the pi, shift and not the symbol. I just put 180 degree because my calculator is in degrees, and 2 to the power 3, just close the brackets, and here you go, the answer is 1. So the slope is equal to 1. What is y? Y naught is equal to integral 2 to 2 because x value is 2, cosine pi t to the power 3, that is equal to 0. You can directly write 0 as well, but since it's writing exam, I'm just writing the step. Y will be equal to m times x minus x naught plus y naught. And here we have y is equal to m is 1 times x minus, what is x naught value? It's 2 plus 0. So the equation is x minus 2. And this is the derived equation over here. So that will be the equation. Y is equal to x minus 2. As you can see here, y equals x minus 2. And the last problem in this topic, a very simple topic here we have, that is equal to m. And what happens is e to the power, whatever is the variable here, you just substitute it over here. And we have to solve it at 0. Why? Because x value, the given point is 0. So here this becomes 0 squared plus 1. So now 0, it's just e. So here slope is e. That's it. Now what about y value? Y is equal to integral 0 to 0 e to the power minus t squared plus 1. And over here what you do is equal to 0. Why? Because 0 and 0, it will just dissolve to 0. Now then we will write the equation of a line. Y is equal to m times x minus x naught plus y naught. And here we have y as it is. What is this m? It is e into x minus, what is x naught? It's 0 plus 0. So it will be e multiplied by x, y. So this will be the answer. It will be e multiplied by x, ex. So that is it. So this is the answer which we got. But write it up together. Y equals ex. The steps are important. Make sure you write these steps and then you write the final answer. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will use substitution to compute integrals. It is from the lesson 5.6. There are various different types of questions involved. Some can be used by u substitution. Sometimes we have to split the denominators, and sometimes the u substitution and rearranging the u, various types. We will try to solve all of these problems. Now look at this. Here you can see x power 3 square root x power 4 plus 3. There is no way we have any rules we can apply and solve these terms. So what we do is we try to assume a certain complicated term as u. Now just imagine, for example, in this case itself, if I consider x to the power 4, okay, as u substitution, we consider it as u. Let us derive this. When I derive this, it will be du divided by dx, because with respect to x, I'm going to differentiate it. This is going to be 4x power 3. This is differentiation, not integration. Integral is what we are solving. Integration is what we are doing. But in order to do that, this u substitution involves differentiation at the beginning. Why do we do this is, now imagine we assumed u to be x power 4. We can apply this as u, but what about this dx? And what about this x cube? No, we cannot solve that. So here we are getting 4x power 3. So now this can be, okay, this is a constant, that's fine. But x power 3, we can do some rearrangement and solve it up. But here there are a few rules to remember. If you just do x power 4, then what happens is it will be u power 4 and then we have plus 3. It's going to be complicated because there is a square root. So what we do is, whatever is inside the square root, this is complicated, isn't it? We just take it as u. And then x power 4 plus 3. That is all inside the square root. Why? Because if we have just square root x, we know we can easily solve this. This is equal to x power half. And then when we integrate this, what's going to happen when we integrate it? Just add the power. By power rule, it's going to be x 3 by 2 and divided by 3 by 2 plus c. So we know how to solve this. But we don't know this one, right? So that is why our goal is to get this in terms of u. And now let's do du by dx. When we derive it, what do we get is 4x power 3, and this is gone because it's 0 when we derive it. Now we can rearrange this dx and get over here we can apply whatever is remaining. So what we do is take dx to the other side and this down. So du divided by 4x power 3 is equal to dx, right? Now what we can do is, for the given equation, we will substitute whatever we have assumed. We have assumed u to be whatever is inside the square root, so that becomes u. X cubed, there's nothing, so let us leave it like that. What is dx? Dx is du divided by 4x power 3. Now simplify. This is gone, x cube gone. And integral square root u, this 1/4 divided by 4 means it's 1/4. I'll take it outside. And what is remaining is du. And now I can apply the rule. What is the rule? 1/4 of integral of u power half du. What is u power half when you integrate it? It's going to be u, add 1 to it. I'm directly going to write it. It's 3 by 2 by 3 by 2 du. Now this needs to be rearranged. You can use your calculator. 1 by 4 multiplied by 1 divided by 3 by 2. It's just complicated, but I'll write it out simply. What's going to happen is this is going to invert itself. 1/4 as it is. This will be 2/3 because it's divided by, when you take it up over here, this denominator remains in the denominator, but this, the above term will be in the denominator, the down term will be in the numerator. That is into u3 by 2. I forgot to write plus c. It's not du, it's done. This du is gone. It'll be plus c over here. My bad. So here it's plus c. So the plus c will remain. This cancels. It's 1 time and 2 times. So you will have 1 by 6. The answer would be 1 by 6. Now don't write u to the power 3 by 2. What is u assumed to be? So we'll get that back. X power 4 plus 3. 3 by 2 plus c. This will be the final answer. So in order to solve this, you did all the substitution, rearrangement, and then you got it. Now let me just talk you through about this. Why did we do certain things? Why can't we keep this dx as it is? Because over here we have u, so then we have to integrate it with respect to u itself. So du must be there. You can't have dx. If it is x, then it's dx. If it was t over here, then it will be dt. But here we have u, so it must be u. And we cannot have two separate terms. X and u, this is not possible to be integrated. So now if you did some u substitution and then your x remaining here, then it's not possible to solve it. So whenever we use these methods, all these problems, when you solve it, what happens is the x terms get cancelled. You will get only u term. And numbers, the coefficient is fine. So this is how we solved it. Remember, when we are doing this u substitution, getting the u is very important. There are certain thumb rules. Whichever is a complicated term, which will make it easier, must be assumed to be u. Now, whatever is inside square root, we generally take it as u. If you have e to the power, then we take this entire thing as u. So it's not only inside the square root, it depends. If we have exponential, we will just take this as u. You will understand as we solve more problems. We take u such that we can simplify the other terms as well. Over here there is no other term, so it's fine. But we have to take whatever is inside the square root as u. When you are solving, that's a writing exam question, isn't it? So we have to write in details. Step 1, let me do the detailed steps here. Assuming u, or u substitution, you can just write anything. U is equal to 1 plus 10x. Du by dx is equal to, this is gone 0, it will be 10 only. And dx, you can take that to the other side and you will have du by 10. So this is dx value. Step 2, I'm just going to write it over here at the left. Step 2 would be substituting in the equation. Substituting in the given function and given question or function. So this is the given function. Now what happens is integral square root 1 plus 10x dx, right? Here we will have integral square root u du, not dx, because dx is du by 10. So we write du divided by 10. Now this 1/10 is a constant. We just have to integrate u du. What is the integration of square root u. You do not need to write u to the power 1/2. I'll just write it over here, but you can avoid this step. U power half. Instead of this, directly you can integrate as well. If you remember, this is half. Add 1, it will be 3 by 2. So 1 by 10. I can even do directly instead of 3 by 2. I know it's divided by 3 by 2. It will be multiplied by 2 by 3. I'm going to write it directly. U to the power 3 by 2. Whatever is there in fraction, that will be flipped and written over here when you're multiplying. Or you should just write it divided by, because if it is u power 2, what we do, u power 3 by 3, right? Or you can write it as u power 3 and this multiplied by 1/3. That's also fine. You know, it's just the same thing. Just ignore this. Now here we have done the integration. Don't forget to write plus c. Over here, can you simplify? Yes, you can simplify this 1 times 5 times. So the final answer would be 1 by 15. 5 times 3 is 15. U to the power 3 by 2 plus c. So that must be the solution for the second problem. But oh no, it's not done yet. My bad. What is u exactly? We had taken that to be 1 plus 10 times x. So 1 by 15 into 1 plus 10x to the power 3 by 2, that is 1.5 plus c. This is the final answer. Make sure you write all these steps, step 1 and step 2. This, you can write the final step as step 3, you know. Substitute back, this is back u value. So that'll be step 1, assuming u and deriving du by dx and getting dx and u. Substitute them in the given question and derive it and leave it as u only. And the step 3 would be substituting back the u value. When you substitute back the u value in whatever is given, that'll be the answer. I will solve other problems now, but make sure that you write in your exam in terms of steps. This is step 3. I'm just going to solve it directly. I'm just going to write it as it is and, you know, as simple as possible and get the answer. You can even do that because this is very lengthy anyways. So just getting the answer is very important. Here, the first one was this, and then we substitute back whatever is u. Over here, we got the same answer. Plus c is very important. What happens here? Now, if it was without the square root, just remember whatever is in the denominator, take it as u. If it was fractions here, it was no square root, then whatever is in the denominator, you take it as u. But here we have a square root, so just assume u is equal to cosine x. Du by dx will be equal to sine x. It's positive sine x. Oh, sorry, it is minus sine x, my bad. It's derivative, it's not integration. So remember about these. See, I get confused when I'm doing integration. I know integration of cosine is positive sine, but derivation of cosine is minus sine. And now then we have to write it as dx. So dx would be equal to du divided by sine x. Don't forget the sine, it's negative. See, now this cancels off. Now when I substitute this back, this will be equal to, I'm not gonna write this again. Here sine x will be as it is, divided by square root u, whatever is there inside. Dx is minus, I'll write minus outside, du by sine x. So this cancels off, you're remaining with the integral is there. Integral, I'll write minus sign outside, the negative integral of 1 by square root u. You can write above only du, that's also fine, or you can just write du over here. Now how would we solve this? Here it will be, when you bring this up, it is negative power. This power is half. When you bring it up, it will be minus half. Power is minus half du. Now let me use the power rule. So it will be minus u power minus half plus 1 divided by whatever is the answer. What is the answer here? Half plus 1 is positive half itself. Plus c. Now let me rearrange this. 2 comes up. So it will be minus 2. Why? Because it's half, isn't it? It'll swap. 2 divided by 1. I'm not going to write 1 because divided by 1 will be the same number. And u to the power positive half or square root plus c. Now we'll substitute back whatever we assumed the value for u. U was assumed to be cosine x. cosine x to the power half plus c. This is the answer. Or you might also write it by going a step further. It is square root of cosine x plus c. It's up to you. Let's just look at the answer. What is written? See, they have written this square root x plus c. But since it's writing exam, even if you write it half, you should get the full marks. But you know, generally the square root radical symbol is written back. Let's do the next problem here. Now, do we assume cosine as u? You can, but then there's an issue. Why? Because over here, the more complicated term is sine cubed. So here, what I can do is, if I assume sine as u, then I can write it as u cubed, right? So u cubed can be easily integrated. Let me show you how it's done. Assume u to be sine x, and then du by dx would be cosine x. It's positive cosine x. And now dx would be equal to, dx only will be equal to du divided by cosine x. Now let's substitute back over here everything. Integral. Instead of sine, I'll write u to the power 3 because it's sine power 3, right? It's basically a whole power 3 itself. So sine x, the whole power 3 is equal to sine to the power 3x. It's the same thing. So I've assumed sine to be u, so it will be u power 3. That is equal to same u power 3 itself. Now here then, what is remaining? Cosine x. What is dx? Dx is written, it can be written as du by cosine x. So cosine x cancels off. You have to just integrate u to the power 3 du, which is so simple, isn't it? It'll be u power 4 by 4 plus c. And now substitute what was u? We assumed u as sine x. It's 1/4 sine x plus c. That is the answer. I just realized I didn't put the power 4. So it's 1/4. This is 1/4. U power 4. It should be sine power 4 x plus c. This is a very important thing. Don't forget the power. Here you can see it is power 4, sine power 4 x by 4. Now this 4 can be taken out and written as 1/4, which I did. That's absolutely fine. And this is the correct answer. Solving these problems here. Now look at these two. Don't think u is equal to cosine t or cosine to the power 3, t to the power 3. No, this is wrong. You need to look at the other terms as well. It's just t squared. So you need to assume u to be t to the power 3. Now let's assume u is equal to t to the power 3. Now what happens? Du by dt, because it's not x, it's given in terms of t. That's absolutely fine. It'll be 3t squared. And then we can write dt is equal to du divided by 3t squared. So now it'll be, this will entirely change into t squared cosine u, because t to the power 3 is assumed to be u. Instead of dt, what do we have? Du by 3t squared. T squared cancels off, and you have 1/3 outside integral cosine u du. And what is the integration of cosine? It is sine, positive sine u plus c. And we have to substitute whatever is u back in over here. U is t to the power 3. That's plus c. So that is the answer. What about at the right side? Now here we need to look at this carefully. It is sine t multiplied with cosine t plus 3 whole power 3/4. If I take u as sine, it's gonna be just so much complicated. I will be able to cancel. I won't be able to cancel this because it's inside the power and radical. The power is 3, the radical is 4. So in such cases, whatever is there inside, I need to write it as square root c, because this can be written as radical 4 cosine t plus 3 the whole power 4. This is, sorry, not power 4, it's power 3 outside, isn't it? The above one is power. It's raised to the power 3 and radical of 4. So basically whatever is inside this, we assume to be u, but don't take this power as u. Just take whatever is inside here. So this will be u. U is equal to cosine t plus 3. Now let's derive this. Du by dt is equal to, cosine derivation is minus sine t. That's it. And now dt will be equal to, you have to swap the places, du divided by minus sine t. Now let's substitute whatever is there. Sine t will remain as it is. We have this to be u 3/4. What is dt? It is du divided by minus, I'll write it outside, and it is sine t. So this cancels off. You're remaining with integral of u to the power 3/4 du, which is very, very simple. What is the integration of this? It's minus remains. You add 1 to this. 3/4 plus 1, it's 1.75, or it'll be 7/4. It's going to be 7 by 4 plus c, but don't forget to divide it by 7 by 4 as well. So we can rearrange that and write it as minus 4 by 7. This flips, isn't it? What is u value? We assume u to be cosine t plus 3, the whole power 7 by 4 plus c. This is how we solve it up. And here we go, that's the answers. Now the first one was, yes, 1/3 sine t to the power 3. It's not sine cube t. The t was power 3 plus c. And this one was negative 4 by 6, 4 by 7, cosine t plus 3, 7 raised to the power 7 by 4 plus c. Now here they have not written all the steps. It's very important you follow these steps. So even if you write so much, you should get the full marks. Okay, this is the rearranging of u in terms of u and dt, and then we substitute back in the given question and we get this simplified version. We can cancel the signs and then we solve whatever in terms of u and then substitute back whatever is u. So you must be thorough in integration before we solve these problems. So if you are getting confused, that means you need to be thorough with the formulas, with assuming the values and everything. Then we can solve this up. So what happens over here? Now if I take the second term u, there's no way I can solve this. I need to take whatever is raised to the power. This entire thing becomes u here. So x squared plus 1, this is equal to, you can even write this term is equal to u, it's up to you. Now I've written this. Now here what happens is 2x plus 1 is gone, is equal to du by dx. Dx goes to the other side. Dx will be equal to du divided by 2x. Now what happens here? Integral of x remains. E is the same thing but raised to the power u multiplied by du divided by 2x. This x and x cancels. Now everything is in terms of u and numbers. So it's half integration of eu du. What is the integration of eu? It's the same thing, isn't it? Eu itself plus c. And here we can write eu was assumed to be x squared plus 1 plus c. So integration of this is just this. So that is the answer. So here we go. Again, the solution set, I realize now it's not so much detail. Okay, this is detailed. There are all the steps. They have written it in horizontally, 1, 2, 3, 4. But it's better you write it in detail like this. I'm also not writing in detail, but initially I've written the steps. This is step 1, step 2, step 3. I'll just mention the steps here. This first part, these 3 things are step 1. Until over here, you can write it as step 2. And finally, the answer, when you substitute the value back, will be step 3. And the given question must be written over here in the step 2, and then it's better to solve it. What about the 12th one here? What do you assume to be a u? Whatever is inside. U becomes e to the power x plus 4, and du by dx will be equal to just e to the power x. Because e to the power x remains e to the power x, and this is resolved to 0. Now we substitute it back over here, integration. Look, e to the power x, write it like that only. Sorry, I didn't rearrange this. Du by e to the power x is dx. So we need to even substitute dx value, isn't it? So square root u multiplied by du divided by e to the power x. See, now this cancels off. So what is remaining here? Square root u du. Please note my u becomes v at times, that is u. And the reason why we are using u is that's a famous method, u substitution. You can even assume it to be m. That's fine. M is equal to, and everything will be in terms of m, but it's generally used as u because it's called also u substitution method. And now what happens over here is integral u half du. It's u3 by 2. Now I'm going to write directly 2 by 3. That's fine, because if you've done so many problems, you must be very thorough with this. You don't divide 3 by 2 and then swap it. I'm just going to write u3 by 2. If it's fractions, flip the fraction and write over here 2/3 multiplied with u3 by 2 plus c. Now the last step would be substituting back the u value. The u value was e power x plus 4 raised to the power 3 by 2 plus c. So this is back here. So that would be the answer. Okay, I did some mistake. Let me just check what is the mistake here. Okay, everything is right. Yeah, this is correct. I'm sorry, I think so. The answer set over here is wrong. See, they have written over here correctly 2 by 3. This is all right. But substituting back u, I don't know why they wrote 1/2. It is wrong over here. It should have been 2/3. Okay, this is a mistake. Apologies for that. When I did the solution set, I went through a few of them, but I just didn't get time to go through all of them. So there might be mistakes. I've seen other mistakes as well. Please make sure you solve it by yourself and then compare. See, the question to our answer is 2/3 e to the power x plus 4, the whole 3 by 2. Let's solve these up over here. Now, how would you solve this exactly? Here, don't assume whatever is inside the square, just assume the entire thing as root x. Let's see now, to be very, very honest, I'm also just assuming as I look at these problems. I have not solved these by myself. I've gone through a few of them, but I've not solved all. So I just assume what is the most likely assumption that can be done to solve it. That's how we is, because I can see that if I take this as u as square root x. Now when we derive this du by dx, this is x to the power x raised to the power half. So what's going to happen? Whatever is there, it comes down 1 by 2 and it's raised as minus half, because when you subtract 1 it will be negative half, and then you can rearrange this and write it as 1 by 2. This goes down, it's square root x because power half is square root x. I know this formula as an identity. When you derive square root x, it's 1 minus, I forgot to, no, it's positive, not minus, sorry. It's positive 1 by 2 root x. So I know when we derive, we get this. So I know something can be done here. Square root can be cancelled. So that's why I assume this entire thing as u. And so what is dx value? Dx would be du times 2 root x. Now let's substitute back over here. E to the power u square root x. What is dx? It's du times 2 square root x. And look here, the square root cancels. You have 2 outside, the constant can be removed outside. E to the power u du. The integration of eu is the same thing, so it's du eu plus c. That's the answer. I remember, one of the students before asking me this, when we integrate this, why don't we do u plus 1? See, sometimes some students, right, when they come to this step, eu du, they might have this doubt, because I remember a student asking me long back, and even I was a bit confused and then I realized, okay, when you integrate eu, it's the same thing. It's not the power rule or anything. You don't add 1 to it. It's not like u plus 1 or anything. No. Integration of e to the power u is just eu because it's exponential function. So the reason why I told is, if at all you're getting this doubt, make sure what is the function. Because it's exponential function, we take whatever is up above. If it was any other function, no, we have to take a different u value. Now this is the answer, but you have to substitute back whatever we assume to be u. It's root x plus c. So that will be the final answer. Hope that's clear. It is 2e root x plus c. The next one, whatever is inside this, let's assume as u, because there is no other way you could simplify this. And when we assume that as u, I know when we derive over here, power 2 will also come. So this can be cancelled out. So u will be 1 by x. So what's going to be du? 1 by x is minus 1 by x squared, but let me do it in steps. Du by dx would be this is equal to x to the power minus 1. So here minus comes down, x power minus 2, which can be written as minus 1 by x squared. But I'm sure many of you might know this as identity. Derivation of 1 by x is minus 1 by x squared. You can directly write the answer there. Then we write du is equal to dx to the other side, and this minus divided by x squared. What I did is I took dx to the other side. Now this is the equation we have to look into. Dx, and this x squared to the other side is not down. My bad. It's multiplied. Look carefully. I'll just write in detail 1 by x squared, right? Minus 1 by x squared. Let's move the x squared to the other side. It will be x squared times du, and the minus to the other side, that will be equal to dx to the other side. So this is the substitution for dx. Now let's substitute everything. Cosine u divided by x squared times minus, I'll write it outside, dx will be x squared times du. Now this cancels off. So you have just cos u du. And how do you integrate this? It'll be cosine integration is sine x. It'll be minus sine, not x, it is u plus c. Now substitute back whatever was u value. It was supposed to be 1 by x. That is the answer. It should be negative sine x, sine 1 by x plus c. I'm sure many of you might feel you're thorough with these problems, so you just can skip this video, skip these questions and go ahead. I've got many students requesting me to solve all the problems from 5 to 40, so I will solve all the problems from 5 to 40. So it's going to be a long video. If you want, you can stick through it, but if you already have understood these problems, then just move ahead. Skip this part, which just go to the ones you have difficulties with. Square root natural logarithm x. I know the derivative of natural logarithm x is 1 by x. So I have to assume this as u. So whatever is inside square root, we generally assume to be u. So natural logarithm x. Du by dx would be equal to 1 by x. So du by, sorry, it's not by now. It becomes multiplication. X times du will be equal to dx. So now it's substituted over here. It's going to be root u by x times dx is u times, sorry, x du times x. I'll write it as. It's x times, it's the same thing. I'll cancel this off. So you're remaining with square root u du. We have done the integration of square root before as well. It's going to be u, half plus 1 is 3 by 2, that's 1.5, and when we write it over here, it's 2 by 3 plus c. It's not over, we have to substitute back whatever we assume to be u. It's ln x to the power 3 by 2. Plus c is very important. Now this is writing part. There won't be any options, so if you're forgetting the c, you might lose marks. So don't forget this plus c, because there is always some constant of integration that can be there over here. It can be 0, 1, 2, any number, or negative or positive numbers. What about this one here? I know derivation of tan x is secant square, right? So I'll just take u is equal to tan x. So du by dx is equal to secant square x. And now I'll rearrange du by secant square x will be equal to dx. Let us, write it in proper steps below each other in, proper method. I'm just writing it to the question itself because, I'm just solving it. I'm just showing you the steps over here. So it'll be secant square x square root u times du divided by secant square x. This cancels off over here. So again, you have integration of u power half or square root x. You can write anything, du. It's the same thing. Can you see over here? But it's just that the final answer will vary. It's 2/3 of u to the power 3 by 2 plus c. Now what happens is it's 2 by 3. U value which we assumed was tan x here. Tan x 3 by 2 plus c. So that is the answers. You can see the coefficients plus c, everything is same, but the terms, natural logarithm, over here we have natural logarithm x, over here we have tangent x. So those are the answers. These are the final answers. You can see everything is same, only the values of. Okay, now I forgot one important thing. It is, no, this is correct what we have done. Okay, this is wrong. I thought I had assumed wrongly. See, we have assumed whatever is inside the square root, that is tan x, and then we substitute back inside the square root. The square root becomes half, and then we get this answer. Here, the final answer is wrong. Again, apologies for this. Here, there is no square root. The square root is the error. This should not be there. It is only tan x to the power 3 by 2 because we have already simplified using the square root. So this is correct. This is now correct. Which see over here, u is tan x. The square root was the mistake over there. Now, what about these problems here? In the first one, in fact, we have u itself, du. So what do we assume? You can take anything x or y or t. I think so. Generally, t is taken if there is already u. Yeah, t is taken. Here as well, but over here it's v, so you can take u. Let's solve these problems up. We have square root and square root plus 1. Of course, this is a bit more complicated than this one. And when we derive this, I know when we derive square root, we'll get back square root as well. It may be in the numerator, or if it'll be in the denominator, but still we can work with that. So what I do is assume u, not u, anything, any alphabet other than u. We generally take t is equal to square root u plus 1. Or you can take it as x, up to you. And then what we are doing is deriving this dt with respect to du, because u is the term inside. That will be equal to, or if you're getting too much confusion, right? Because I remember when I was in my school, whenever I get any other term, I used to rewrite this question as x. I mean, it's a very silly thing to do, but in terms of dx, and then just solve it up. Because over here, especially u substitution, I like it as u and x. For some reason, it'll be du by dx. You can do the same thing, this everything over here instead of u, you can assume to be x and then solve it up. That'll be also fine. It'll be absolutely correct, no problem at all. But the finally substitution, substituted back into whatever variable was there. Now let me do a dt by du. Over here, integration will be 1 by 2 root x. I'm not going to solve in detail, not going to take 1/2 and everything. I know the identity of square root x is 1 by 2 root x. But here, since we have u, it's going to be square root u. Plus 1 will be 0. What do we need here? We need du. Take it to the other side. So it will be dt is equal to du. And this is multiplied here to square root u. Now let's substitute back in the question. It's going to be 1 divided by, what is square root, no, leave this, square root u. What is square root u plus 1? Whatever is inside the bracket is considered to be t. And du is 2 square root u dt. Now the square root u cancelled off. You have not 1, it's 2 divided by t dt. What is 1 by x integration? Now natural logarithm derived is 1 by x. Over here, just remember, write the t outside, it will be natural logarithm t, the magnitude of it, plus c. So that must be the answer, but substitute back whatever we assume t to be. It is square root u plus 1 plus c. So that must be the answer. So these are the exact steps to solve. That is the answer. Now here you don't need to write magnitude. You just have to know that you can't have negative numbers here. So that will be the answer. It's not required to write magnitude. You can just write brackets. It's fine. What about the next one here? Whatever is down, when I derive power 2, it's going to give me power 1. So this will be cancelled off. So let me assume whatever is over here, u is v squared plus 4. Let me take it as du by dv here. That'll be 2v. That's it. And now let me write it in terms of v. So it'll be du divided by 2v. That is equal to dv. Now I'll substitute everything in the given question. V remains, but the down term becomes u, and dv will become du by 2 times v. This v and v cancels off, so you have this 1 by 2, which is in the denominator. I'll take it out, half integral 1 by u du, and that is half of natural logarithm u. This is a habit which I do, but anyways, you can just remember u must be positive. So let's substitute back. What is u? U value was v squared plus 4. Now here you don't need the magnitude, doesn't matter what value you take, it'll be positive, so there's no problem at all. So that is the answer here. Half natural logarithm of v squared plus 4 plus c. Then what else we got? We have over here, again it's similar problem. Okay, now when we solve this up, we will get 1 by x, see natural logarithm. So don't take this power 2 as u, just whatever is inside. Natural logarithm x plus 1 is equal to u. And now let's solve it up. It's going to be 1 by x equals du by dx. We need dx value. So dx will be equal to du times x, or x times du. This is at the right side, it's u. Or x times du, it's the same thing. I'll substitute back in the given question 4 divided by x. Whatever is there over here, it becomes squared. And this becomes x times du. So this x cancelled off. You have 4 integral 1 by u squared du. What is 1 by u squared? We can take this up. It'll be 4 integral u to the power minus 2 du. That is 4 of, not integration now, we are, let's use the rule. It'll be u minus 1 by minus 1 du. It's just that the sign changes here, minus 4 u minus 1, not du over here, my bad. It is plus c. Once we apply the integral rules, it's plus c. So that's the answer. Now all I need to do is substitute back whatever is u. Minus 4 times ln x plus 1 plus c. This is power minus 1. I can take it to the denominator, so it will be minus 4 natural logarithm x plus 1 plus c. That must be the final answer. Here we go. It is. Now they have not done this last step because it's minus 1. I took it down, but you can just leave it like that as well. But I would suggest you go ahead with this step as well. It's writing exam. You can get it as simplified as possible. The next problem here, we have tan 2x. Now there is no way you can use tan x. There's no rule to integrate tan x. But we can integrate sine divided by cosine, because tan theta is equal to sine theta divided by cosine theta, right? I'm just going to substitute that. Instead of tan, now we don't have theta, it is 2, 2, 2 and x instead of theta. This will be equal to integral of sine 2x by cosine 2x dx. Just remember that. So now what is u? U will be whatever is in the denominator, cosine 2x. I hope you remember I told in one of the previous problems. Here, what is down? The denominator is considered to be u. Now let's derive this. Du by dx would be equal to minus sine 2x. Now it's not over. There's a chain rule. Once this is done, whatever is inside is also derived. It's 2. This is the chain rule. Cosine 2x derivative is minus sine 2x. But then we derive whatever is the x value, because it's not just x, there is something else as well. 2x derivation is 2 because 1 is dissolved to 1. X will become 1, so 2 remains. Now then, what is dx? Dx will be equal, going up, this goes all down. It'll be minus 2 times sine 2x. So now let's rearrange this question. Sine 2x remains. Divided by cos 2x is u. And what is dx? Dx is du divided by minus, I'm going to write it outside. Because why? The reason why I always write minus outside is sometimes if I put it inside here, I forget it in the next step. So whenever I put this out, it's there over there, isn't it? Now it's up to you. You can write it over here, take it out later, but it's just a habit which I follow so that I don't forget the negative sign. Because it's easy to forget the sign when you go to the next step, when you cancel it. See, now this is cancelled. I tend to forget the sign. So that's the reason I always put it outside. So it'll be minus 1 by 2 integral 1 by u du. We know the integration of 1 by u, that is natural logarithm u. So negative half ln u plus c is the answer, but you need to substitute back what is u. U was considered to be cosine, it's cosine 2x, not sine, cosine 2x plus c. So there we go, that is the answer. It is minus half natural logarithm cosine 2x plus c. Now here it is very important to put this. Now why? Because there is a possibility that there can be a negative answer here. There is positive and negative answer in a cosine function, isn't it? It starts from up. So that's why we put the modulus symbol. Now, why didn't we put in the previous problems? We had the similar one, natural logarithm. Let's go back 1 second. Here, because it's squared, doesn't matter what value of v, we will have a positive answer. And then we are adding 4, it'll never be a negative number. That's why there's no need of the modulus symbol. Here as well, square root u, square root of any, only positive numbers is possible. You can't have a negative number when you have square root because it's undefined, right? It'll be imagined numbers. So whatever is u is only positive. Already we know that. And you're adding 1, no matter what, it'll be negative. So we just put the brackets. But here, there is a possibility that cosine 2x can be negative. So to avoid that, we write the modulus symbol. So if you're wondering why did we write it over here and why didn't we write it over here, that is the difference. Because over here, cosine 2x, there is a possibility of it being negative. So it'll be minus, modulus will make it positive, and that's the answer. Now, what about these problems? It looks a little big. They're all same way to solve. Okay, now here, this one, don't think whatever is inside square root or the denominator. No. When I look at the top term, I know it's sine inverse x. You need to know the rules of the derivatives here. If I assume u to be sine inverse x, what is du by dx? That is 1 by square root 1 minus x squared. To be very honest, I didn't have this, identity in my mind. But I knew over here when I looked at it, okay, this is the identity. I remembered it. So that is how we do it. Now, let's rearrange this. Let me take dx to the other side and this to the other side. So it will be square root 1 minus x squared. Du is equal to dx. So we can rearrange everything here because this will cancel off. U to the power 3 divided by square root 1 minus x squared, and this dx will become square root 1 minus x squared du, and this cancels off, so you have basically integration of u cubed du. What happens here? It will be u power 4 by 4 plus c. Here we are to substitute back whatever is u. We can write 1/4 u is sine inverse x plus c. This is it. So this is the final answer. And we can see here it's 1/4. Now they have written divided by 4. It's the same thing, sine inverse. Okay, I've forgotten one important thing. Power 4. See, I've done this even before in one of the problem. So I just checked the answer because, whether I'm right. I do silly mistakes. See, everything is right. The power 4 was missing. U is raised to the power 4, isn't it? U is sine inverse x, correct. The whole raised to power 4. This is the correct answer. So that's what was missing. That's how we solved it up. Now what about this one here? Look, secant square integration. I know it is tan x. So I'm not worried about this. I'm just worried about these two. So if I just assume x cube as u, that's more than enough. Because when you derive it, it'll be power 2 and I can cancel this off. Because integration of secant square is known. It is tan x. So what I'm going to do is u is equal to x cubed. Du by dx is equal to 3x squared. And now here it will be du by 3x squared, that is equal to dx. Now let's substitute everything back in the given question. X squared secant square u, not x, times dx will become du by 3x squared. This x squared cancel. Now everything is in terms of u and a number. the number outside, 1/3 is taken outside, it will be secant square u du. The answer will be 1/3 tan x, because integration of tan secant square x dx would be tan x. But here it is u, so I'll write tan u plus c. What was u assumed to be? It was assumed to be as x cubed. So I'll put it back over here, x cubed plus c. And here we go. That is the answer. So 1/3 tan x cubed plus c. Looking at the answer over here, okay, they have not at all taken. Okay, oh, I'm so sorry. This is not the question, It's a different question altogether. This is wrong. Apologies for that. This is the correct answer. I have not done any error over here. It'll be tan x, and yes, it'll be, you are to substitute whatever was u back over here, and it'll be x cubed. So please consider this the correct answer and ignore what was there in the solution set. I'll just leave it over here for a second. You can write it down, pause the video, take a screenshot or something. Moving on to the next one, 23rd, there's A and B. Okay, these ones, right? You can look, they are much similar, but this U consideration will be different over here and over here. Let me tell you why. Now, looking at this one is a bit, this is easier. If you know square root 1 minus x squared, it's sine inverse, isn't it? So, what is the sine inverse formula? If you derive sine inverse x, it's going to be 1 by square root 1 minus x squared. So we need x squared here. If you have x squared, then we integrate this, it's going to be sine inverse x in the final answer. But if we take x squared, there is x4 here, x to the power 4. Okay, now if we assume u is equal to x squared, what can I do? That's fine. Let me derive it, du by dx. I'm going to get 2x. This is also very helpful because I can remove this x off now. Because over here, du by 2x will be equal to dx, right? So when I substitute over here, denominator x, numerator cancels off. So everything is helpful, but what about this? I have x power 4. So all you do is square this. You have assumed u is equal to x squared, right? Square this on both the sides. So it will be u power 2 is equal to x power 4. So instead of x power 4, I can write u raised to power 2. And then here, instead of x, we have u, and absolutely integration of this will be sine inverse u. We can do that. So what we do over here is, after this much, after you understood this, here I'm going to rewrite this as x divided by square root 1 minus u squared, because x power 4 is u raised to power 2. And this dx becomes du divided by 2 times x, and this cancels off now. Now what is remaining? I'll just erase this a little bit over here. So here now you're remaining with integral this 1 by 2. I'm going to remove it outside. I'll write 1 divided by square root 1 minus u squared du, which is equal to, I'll just write it over here, half of sine inverse of u plus c. Now what was u substituted as? U is equal to x squared. So sine inverse of x squared plus c is the correct answer. So this is it. That will be the final answer. It's half sine inverse x squared plus c. It's not x. We did that, in the manipulative method. We took u as x squared, and then we used u squared in the question because u squared is x power 4, and then we could easily use the sine inverse formula. But we cannot use whatever we did over here to the next problem. If we take u as x power 2, the derivation will be 2x. Here we will have du by 2x, which doesn't help us. If we cancel it, still x power 2 remains. So what we need to do over here is take x power 4, u as this itself. But you can't just take u as x power 4, because then it's a problem. We cannot solve it when we go in the final stages. You have to assume whatever is inside the square root as u, and this will become 0, and then we can cancel this off. Let me show you. Whenever the difference is just 1, just take whatever is inside the square root. The power should be higher than the above. that is assumed as 1 is equal, u is equal to 1 minus x power 4. So what happens when you assume derive it du by dx? It's going to be minus 4x power 3. And let's rewrite this, du divided by minus 4x power 3 is equal to dx. So now we'll substitute all these things in the given question. It's going to be x cubed as it is. Whatever is inside the square root is u. And what is dx? It's du. There's minus sign, which I'm going to write it outside the integral, divided by 4x cubed. Then cancel this off. So you're remaining with minus 1/4. I'm going to write this out. It's integral 1 by square root u is 1 power half. It's u power half du. So what happens is here, it'll be integration of negative half, u raised to negative half, because I'm just going to get it to the numerator, the power becomes negative. And then you have du. Let's solve it up. It's minus 1/4. And what is this? It'll be u power half, isn't it? Why? Because minus half plus 1 is half, divided by half, which will be multiplied by 2 by 1. You don't need to write 2 by 1. You can just write 2. That's enough. Plus c. It's not du anymore. It'll become plus c. That is integration constant. Now here you can write 1 time, 2 times, and you're remaining with minus 1 by 2. What is u value? U value was 1 minus x power 4 the whole half. Sorry, it's 1 by 2 plus c. You can also rewrite this as minus half. It will become square root 1 minus x power 4 plus c. It's as it is we had got initially. It was written in square root radical. Let us look into the answer. Here we have negative half. They have not written in radical. They have just written the power. It's the same thing. Over here, this is absolutely fine. Let me clear this. We can even go ahead and write in the next step square root 1 minus x power 4 plus c. This is the correct answer. These two problems are also similar to just the one which we solved a while ago. In the first case, we do not need to assume u as the entire denominator. I'm just going to assume u one more than this because there's a big difference. I'll write u is equal to x power 3. I'll tell you why. Because du is equal to, du by dx is equal to 3x squared. And what is du by 3x squared? That is equal to dx. Now when I rearrange this, x squared, now I'll write this in a minute, but du by 3x squared, this x squared cancel. So it really helps me a lot with that. But I do not have x power 6. I have just x power 3. How about we square this? U is x power 3. Let me square both the sides. And what's going to happen? It's going to be u power 2 that is equal to x power 6 because we multiply the powers here, isn't it? 2 times 3 is 6. So here I'm not going to write u, it's u power 2. And now this integral, it's 1/3. I'm going to write it out 1 by 1 plus u squared du. It's similar to 1 by 1 plus x squared dx. It's tan inverse x. So the answer is 1/3 of tan inverse u in this case plus c. That is equal to 1/3 tan inverse. What was u initially assumed to be? It is x cubed plus c. So that is the final answer here. That's it. So it's 1/3 tan inverse x cubed plus c. What about this one here? Here what we do is we will have to assume u as the entire denominator because then only the numerator can be cancelled. It's 1 plus, don't just do this one term, the entire thing in the denominator. And du divided by dx would be equal to 6x power 5. And let's rearrange this. It'll be du divided by 6x raised to the power 5 is equal to dx. And let's substitute back in this given questions. So we have x power 5 as it is divided by 1 plus x squared is u, and dx is du divided by 6x to the power x raised to the power 5, which cancels that out. You're remaining with 1/6 of 1 by u du. This is natural logarithm now. Don't try, it's not radical or anything. Don't write, and there's no square root. So don't write this as u raised to power minus 1, then we cannot solve it because it'll be divided by 0, it's undefined. We have to use natural logarithm 1 by 6 ln u plus c because we have used the integration. It's 1 by 6 ln, what is u initially assumed to be? 1 plus x raised to power 6 plus c, that'll be the answer. And that's it. So here again, I forgot one important thing. We do not know the x value. No, it doesn't matter here. You can write the brackets. Why? Because whether it's a negative or positive number, it's going to be positive itself, and you add with the positive, adding with 1, it'll be always positive. So this is fine. This is the correct answer here. So this one, 1/6 of natural logarithm 1 plus x raised to the power 6 plus c, that's the correct answer. Okay, these are not like the previous ones because I can see it's 1 plus x divided by 1 plus x squared. There is no way if I take the denominator, I can cancel the numerator because there is plus over here. If it was single term, then it's a different thing. Whenever you see such problems, where you have 1 plus x in the numerator, even in the denominator it's 1 plus x, what you need to do is split this out, like make them fractions. Integral here, imagine I have x plus y divided by 2. Can I write this as x by 2 plus y by 2? Yes, the denominator is same. I can write together x plus y, isn't it? The same way, I'm going to split this denominator to 1. It's 1 plus x power 2 plus x by 1 plus x squared. So the denominator is same. And I've just split this. I can rewrite this as the above question. That's absolutely fine. Dx is also split over here, both the problem. This is integrated. Now what is the integration of 1 by 1 plus x squared? Now I can do u substitution over here. No, do you need a u substitution here? 1 by 1 plus x squared is tan inverse. I can directly tell it's tan inverse x. You can't use u substitution because then it will be error because there's no x to cancel up with. But here I can't do that because there is x in the numerator. So what I do is, this is done. For this part, I need to do u substitution, which I'll do it over here. U is equal to 1 plus x squared. Du will be equal to 2x, du by dx. Okay. So what is du by 2x? That is equal to dx. Now I will substitute over here. Let me solve that question up over here and then write the answer because I've written the answer over here already. It's plus c1 because there are two c's, or I can write the answer and directly write 1c because c1 plus c2 will be just c. 1 plus x squared. You can write this and then solve first part and second part individually. So step 1, solving this one answer. Then step 2, and then finally write the sum of those both. Here we have x by 1 plus x squared, and we have assumed many things. X divided dx is there. That's a very important thing. Down denominator is u, and dx will be du by 2x. Cancel the x's. So over here, what is remaining exactly? Your remaining, the integral and all is there here as well. So it'll just be 1 by 2 integral. This 1 by 2 is there. 1 by u du. Let's solve this up. Half of natural logarithm u plus c. That's the answer. But you need to substitute back what was u initially assumed as. It was 1 plus x squared plus c. So let's substitute back the answer here. Because we have already 1c, c1. We'll consider that to be c2. It's half natural logarithm of 1 plus x squared plus c2. Or we can write this together as tan inverse x plus half natural logarithm of 1 plus x squared plus c. That's it, because both are just constants, right? You can add those two numbers and that'll be just another number. That should be the final answer. It's tan inverse x plus half natural logarithm 1 plus x squared plus c. Now here you do not need to put this modulus. Why? Because anything, any squared, see the x squared will be positive number only, because when you square it up, it'll be a positive number no matter what, and you're adding 1, so you don't need to put the modulus. Absolute value is not required. What about the next problem here? Okay, this is a bit easier because I can see the denominator is as a squared minus b squared. That is equal to a plus b, a minus b identity. So it's a squared, differences of squares. So let me write this as 1 plus x divided by 1 plus x, 1 minus x dx. So it cancels off, right? What is remaining exactly? 1 by 1 minus x dx. This is what you need to solve for. Now, how would you solve this? You can just assume whatever is down to be u. So u will be 1 minus x, because we do not know the rule for this. It's not 1 minus x squared or something. We don't have an actual rule. So we write u is equal to 1 by 1 minus x. Derive this, du by dx is equal to minus 1. So what is basically dx value? This minus 1 to the other side, minus du will be equal to dx. So now substitute back in this particular question. We have simplified the question already. Here it's going to be 1 by u minus, I'm going to write outside du. So minus, what is 1 by u? It is natural logarithm u plus c. Now what was assumed to be u? That was 1 minus x plus c. So that is the final answer. It's negative natural logarithm of 1 minus x plus c. Okay, here now, I forgot to write one important thing. This is correct, everything is correct, but modulus symbol, that's modulus means absolute value symbol, is very important. Why is that? Because I have minus x, so x can be phi. It'll be minus phi plus 1, that is equal to minus 4, which will make it undefined. So I have to write this modulus. If it is positive over here, see in this case, it's x squared. No matter what, you take a minus value, minus phi, squared will be, this whole squared will be 25. So it will be 25 plus 1. If x is minus phi or plus phi, negative or positive, it's going to be positive only, the answer. Not in this case. So that's why we write the absolute value or the modulus. So it's minus, yeah, that's the correct answer. How about these problems? Now these do not need to be split like what we did just now. Why? Because over here it is just a single term, 3 root x. But this is now another way, a tricky way. If you try by any u substitution method, this cannot be solved. If you take an x cube as u, let's derive du will be 3x squared. Now it will be divided by 3x squared. Can you cancel this? No. What if I take square root as u? Square root as, okay, this will help us a little bit. Du by dx, that'll be minus 1 by, sorry, it will be positive 1 by square root x, right? This is the identity for square root x derivative. But you know, this is assumed to be u. This cannot be cancelled if you assume this to be u. Now what do we do? What we can do is, if we take this entire thing as u, it's not gonna work out. We need to manipulate this x to the power 3. So how do we manipulate this? Instead of u be taken as x power 3, let's take it as 3 by 2. Why? Because this is radical, that's power half. So x power 3, and this is x power half. That's basically, we have x power 3 in it and we have square root x in it. When we simplify this, we are going to get 3 by 2, isn't it? Now what happens if you derive this? Du by dx will be equal to, when we derive this, it's just going to be 3 by 2. We have to subtract this by 1. 3 by 2 is 1.5, isn't it? So we are remaining with x power half. What is this exactly? This is 3 by 2. Sorry, x it is, not u. The root radical of x or square root of x. That is du by dx. What do you want over here? You need dx. So let's take dx to the other side and all these terms to one other side. It'll be 2/3 du by radical x or square root x, that is equal to dx. Now we can simplify a lot. What happens here? It's going to be integral 3 radical x, square root x, sorry, 1 by x cubed will be 1. See here, we need what? X cubed, right?
how can we get x cubed from u? We can't write u. U is 3 by 2. So what do we do this? Here we square it up. U square over here, let's square this, x power 3 by 2, the whole power squared. This power 2 cancels. You're remaining with u x cubed. I should have told that earlier, but anyways, this is how we get x power 3. So when we divide this by 2, we can just square both the sides and get it, right? So now this is u power 2 dx. Dx is, sorry, du. It's du and all these terms, du by square root x multiplied by 2 by 3. So what can be cancelled? 3 can be cancelled with this, square root can be cancelled, 2 can be written outside, integral 1 by 1 minus u squared du. See, now this is tan inverse. So I can easily write this as 2 tan inverse of u du. And what is u assumed to be? It can be written as u is equal to tan inverse of x to the power 3 by 2. It's not du, sorry, after you use the integral, it is plus c. Yeah, this is the answer. It should be 2 tan inverse of x 3 by 2 plus c. You can see here, that's the correct answer. That is how we solve it up. Let's go back over here. I'll just run through it again. We are not able to take u as x cube or x power half or square root x. It's not possible. So what we do is we need to assume u such that when we derive it, we have square root x. So all you do is whatever is the power, you divide it by 2. That means the square root is involved. So here, this is as saying as we have x cubed times the square root x. So here when we derive this, we will have 3 by 2 x power half, which is square root x. Now we can cancel this off and then rearrange the terms and get dx and substitute back over here. 3 root x divided by 1 plus. The problem is we have x 3 by 2 as u, not x power 3. If you square on both the sides, you get u square equals x power 3. And that can be used as u square, instead of x cubed, we can write as u squared. And dx becomes du by square root. All these terms needs to be written. Cancel out whatever can be cancelled, and you're remaining with 1 by 1 minus u squared, which is tan inverse. So that's it. Look at the next one. It's the same way. Only thing is over here, we have phi by 2 to do. So let me show you how it is done. We assume u to be x power phi divided by 2. Remember, u power 2 is equal to x power phi. So u squared. Now we derive both the sides du by dx. That is going to be phi by 2 times x power. Now what is x power phi by 2 plus minus 1? It's 3 by 2. Now if you look carefully up above, we don't have x raised to 3 by 2. But what exactly is x raised to 3 by 2? It is 1.5. X is 1.5, right? So this means there is one whole of x and one half of x. So that is x and square root x. Or over here, if you simplify this, it's much easier. In the numerator, this is equal to integral x power 1 and power half. That's going to be 3 by 2 or 1.5 divided by 1 plus x power 5 dx. So this is enough for me. It's better to simplify this rather than rearranging this. So now let me write what is dx. Du will be equal to, take this 2 to the other side, phi down, x3 by 2. That is equal to dx. Now let's substitute everything what we have assumed here. x3 by 2 remains here for now. 1 plus, what is u squared? X to the power 5, that is u squared. We have du 2 times, I'll write, let me write it over here. 2 times du divided by 5 times, this all multiplied, x power 3 by 2. That cancels off. 2 by 5, I'm going to write it out. 2 by 5. What is remaining? Sorry, it's integral 1 by 1 plus u squared du. Now again, we have tan inverse here. It's 2/5 of tan inverse of u plus c. But what is u exactly? 2 by 5th of tan inverse of x raised to the power 5 by 2 plus c. So this is the final answer here. We can see it's 2/5 of tan inverse x raised to 5 by 2 plus c. Okay, this is another type. It is not like the previous ones. It is a little different here. See, there is no way we can assume the denominator and solve the numerator because we have again plus. But we can't even split this. If you split 2t by t plus 7 and then 3 by t plus 7, it's not helping. We don't have an identity to solve. If it was x squared plus 1, like the previous problems, we were able to solve because there were identities. But this do not have any identities even if you split. So what can we do? We have to do another sort of manipulation here. Let's assume u as whatever is the denominator for now. U is equal to t plus 7, and let's derive this du by dt is equal to 1. This is 0. And what is basically dt? That is du is equal to dt when we take it to the other side. Okay, this is helpful, but whatever is down is u, dt is du. But what do we do in the numerator? There's nothing we can do, is it? Look at this given term, u, not given, sorry, assumed term, u is t plus 7. What if I tell what is t? What is t in this? Let me take 7 to the other side. U minus 7 is equal to t, isn't it? Now, can I substitute that over here? U instead of t, I'll take it as u minus 7 plus 3. Now everything is in terms of u. Can I solve this? Yes, absolutely. Let me simplify this. It'll be 2 multiplied with u and minus 7. So it'll be 2u minus 14 plus 3 divided by u, that is du. And here we have 2u minus 11 divided by u, that is integration of du. And what else? Let's split them up. 2u by u minus 11 by u integral du over here and over here integral as well. This is minus. So first one will be just 2 integration of 2 du. The second one will be minus integral 11 by u du. Don't we know how to integrate these both? Absolutely, we can easily integrate them, right? I'm just going to write it up over here. The first one will be integration of 2 into u. That's it. I'm not going to write plus c1 plus c2. I'm just going to write 1c together. Next one will be minus 11. 1 by u will be ln modulus u plus c for both of them. And here, what was u assumed to be? U is t plus 7. So it's 2 times t plus 7 minus 11 ln. Here, write modulus t plus 7, absolute value or modulus plus c. This is c over here added. Now we can simplify it further, like you can multiply this if you want. You can leave it like this. Let's just look into the answer, how they have written. They've just left it as it is. So it is 2 times t plus 7, that is 2u, minus 11 natural logarithm, absolute value of t plus 7. Why? Because if t is, say, minus 10, minus 10 plus 7 is minus 3, which can be a negative value. So we write modulus of this absolute value plus c. This problem as well is similar to the previous one because inside the radical over here, it is not more than 2. If it was 3, then it was easier. But here we have power 2 in the numerator and there's only t. We can't solve this in any easy way. So what we do is whatever is inside the radical, take it as u. U is t plus 3. Let us derive both the sides. It will be du is equal to du by dt is equal to 1. And let's take this dt to the other side. It will be du is equal to dt. So what is now t or t square? From this, how can we rearrange and write t? So u minus 3 will be equal to t. But the problem is we have squared, so we have to square both the sides. And now apply the square. This is a minus b the whole square identity. It will be a squared minus 2 times ab plus b squared. Minus 2 times ab plus b power 2. Same way we write u power 2 minus 2 times 1. Sorry, 2 times u. A is u and b is 3. Don't write the negative symbol because it's already taken care for. So it's 2 times u times 3 plus 3 squared. That is equal to t squared, isn't it? So it's u squared minus 6u plus 9. That is equal to p power 2. Now we will substitute all that we know and simplify. It's integration of u squared minus 6u plus 9 divided by, what is this entire thing is u, radical root 3, right? I'll write it as 1/3 because that is equal to radical 3. Because it's 1 whole power 1 divided by whatever is in the radical. That is in terms of du, because dt is equal to du. Now we can divide these terms. First term would be u squared divided by, see, I'm not going to write, you can write it like this, u squared divided by u power 1/3 minus 6u divided by u power 1/3. Then plus 9 divided by u power 1/3. This is one step, but I'm going to directly write what will happen here. I'm just going to write an easier way. This is one way possible. Okay, you can write it like that, no problem. Another way is, since u and u is there, all you write is u power 2 minus 1/3. Then du, oh, we can write that later, sorry. Let me just write it once because there are three terms, minus 6u, what is the power here? If it's nothing, it's 1 minus 1/3 plus 9u raised to minus 1/3 because this is just brought up. We have split this to all the three terms and then we can write this. You can skip this step. If you want, you can write it. It's up to you. Entire thing times du. We have to put bracket because it's more than 1. Okay, it should be properly written. And now what else? We will simplify this. u2 minus 1/3. You can use your calculator. Over here we can write it as 6 by thirds. So multiply 3 and 3, it will be 6/3, it will be 5 by thirds. Minus 6 minus, sorry, it's not minus 2 by thirds, it's positive 2 by thirds. 2/3 are remaining. Plus 9u negative 1/3 du. We can apply the power rule. Now you don't need to write this individually for each term, it's understood. I'll just apply the power rule over here. It'll be u 5/3 plus 1, that's going to be 8 by thirds. And I'm not going to write divided by 8 by thirds, I'm just directly writing 3 by 8 here. Minus. What's going to happen here? I forgot to write the u itself because it's not 6 raised to 2/3. It's 6 times u raised to 2/3. Now the 6 remains multiplied by, when you add 3 to 1 to 2/3, it's going to be 5/3. U raised to 5 by 3, and here what's going to happen is it'll be 3 by 5 plus 9. What happens here? You add 1, it's going to be 2/3, and here it'll be 3 by 2 plus C. This is it, but you can simplify this. You can simplify and write it as 18 here, and that's it. But then you have to substitute what was u. So u is 3 by 8 times t plus 3, over here will be 8 raised to 8 by 3, minus 18 by 5 times t plus 3 raised to 5 by 3, plus 9 times 3 would be 27, and half of that would be, my mind is, just tired. It's 13.5 for now. That's a 13.5, or instead of, I don't know why I did that, I'll just write in fractions. 19 times 3 is 27 by 2 because we have written everything in fractions. T plus 3 the whole power 2/3 plus C. This must be the answer. I hope this is correct. I hope I've not done any mistake. There is some mistakes here. No, I think so, it's all right. 2/3. Here, let's see the substitution, the solving. 9 times 3 would be 27 by 3. I believe what I've written is correct and this is wrong because over here we have 2/3. Yeah, you have to multiply 9 times 3. Okay, thank God. Whatever I did, this is absolutely correct. You can see here the same answer, but there is one error over here. What we had got, it is 27 by 2. That is the correct answer. It's not 18 here. 18 is for the previous one. This is 27 by 2. So this is how we solve this problem. A bit lengthy because we had squared, we had to split it out and all that. There are no exact steps over here, but if you follow this, what I've done, this is the accurate steps. This problem is not similar to the previous problem, but it's a different way to solve altogether. Here, there is no method we can solve this directly. You can't take u as something because there's nothing up over here. So what you can do is you can just assume the down thing entirely to be u is equal to square root 1 plus square root x. And then we have to find dx. So what we will try to do is we'll find what is x value first. We will simplify everything, get x and then derive it. What I mean is we'll square both the sides. It's going to be u squared 1 plus square root x. Take 1 to the other side and u squared minus 1 is equal to square root x. Square again both the sides. It's going to be u squared minus 1 the whole squared is equal to x. Now if I derive both the sides, what's going to happen? I can get dx by du. Let's derive both the sides with respect to u. So this will be 2 times u squared minus 1, the power 1, so I'm not going to write it. And what is the derivation of inside terms? It will be 2u minus 1 will be 0 is equal to dx divided by du. So now I'll just take this du to the other side. It's going to be 2 times u squared minus 1. This is, I'll just simplify here only. 2 times 2 is 4. 4u multiplied by u squared minus 1 will be equal to dx. This is du times du is equal to dx. Now we can work on this given question. See, 1 divided by, what is this entire thing? It's u. What is dx here? Dx is this entire thing. I'm going to write in the numerator itself. It's 1 by 4u into u squared minus 1 du. And now this u and u can be cancelled and everything is in the numerator, right? 4, I'll write it outside because it's the numerator, it's a constant. And bracket u squared minus 1 du. Can we integrate this? Of course, we can easily integrate this. 4 multiplied with, what is the integration of u squared? It will be u power 3 by 3 minus u plus c. So we can multiply 4 inside or we can leave it outside. Now we just substitute what was u. So these big things, right? We'll substitute it back. You can just write the 4 outside because you have just multiplied 4 2 times inside. You can write it like this as well. It's distributive property. Let me do it like that. 4 by 3. What was u? It's root of 1 plus square root x the whole power 3 minus, multiply 4 over here. What is u? It is root of 1 plus square root x. So that is the final answer. And don't forget the plus c. So that must be the final answer. Let's look into the answer. Yeah, it's 4/3. Now they have written by 2. Why is that? Because I've written square root. That's absolutely fine. You can write the next step divided by 3 by 2. It's up to you. Here they have written the answer as 4/3. Not writing the square root, they have written 3 by 2. I've written the square root to the power 3. It's the same thing. And even over here, it's minus 4 times 1 plus root x. But here what they have done is half plus c. So this is how we have solved this answer. This is how to solve it. And it's a bit tricky because, there's no exact way to, know, okay, this is the method for this problem. Looking at the problems, you need to think a little bit and then you can get this method because there's no way you can solve this otherwise. So whichever they give you for writing, no matter what, they can be solved in one way or the other. Most of the time, a simple problem will be asked, not complicated like this. But if you can see there's nothing to be done, then take this entire thing and try rearranging and get in terms of x and then derive both the sides with respect to u and solve it. Let's go to the next one. Okay, here another problem. It's another tricky method. Let's look at this first. See, there is square root x to the power 4. If I take u as power 2, you will have, u square minus 1, and then I can use the inverse trigonometric function identity. And if I take u power 2, see, if I assume u is x power 2, sorry, when I derive it, x, there can be something that can be done over here, right? So let's derive this. It'll be du by dx, that is equal to 2x. And now let's rearrange du divided by 2x will be equal to dx. But what about this x power 4? Let's square both the sides. U squared will be x power 4. So we can substitute this as u squared. Now let's write everything over here. 1 divided by, what is x? X as it is, because it has to be transformed to something else now. What is this x power 4? It is u power 2 minus 1. Dx will be du by d2x. Look here, it doesn't cancel off because they're in the denominators. So first let me take half outside, integral 1 by x, and x will be x power 2 square root u squared minus 1 du. Now we cannot solve this because you have x and u. We need to get everything in terms of u, but we know u value is x squared, right? So I can write this as half integral 1 by u square root u squared minus 1 du. Now you might remember the identity. This is secant inverse. 1 by u square root u squared minus 1 is secant inverse, right? So half of secant inverse of u plus c. This is the answer. But u was assumed to be x squared, so I have to just write 1 by 2 secant inverse of x squared plus c. This is the final answer. So here what happens is when we simplify it, you get x squared, but make sure you substitute back u, and then see, looking at this identity, you will understand this is a secant square identity, but you should have u over here. It's not any other term. It's not u square as well. It should be 1 by u into square root u square minus 1 is secant inverse. So derivative of secant inverse x would be 1 by x square root x square minus 1. So it's just that we have over here u, so we write u and then we substitute whatever was the assumed u value. So it should be half secant inverse x squared plus c. That's how we solve this. Now we move on to the last type of problem where the limits are given. It's from 0 to 2 and different types of limits. But the problems are similar. We have already done these before. So what do we do here? You just have to take whatever is inside the square root as u. U substitution, u is equal to x squared plus 1. Now derive it, du will be 2x plus 0. We don't need to write it. It's du by dx here. We need to get what is dx. So it'll be du by 2x, that is equal to dx. We got it. How about we substitute over here? This is x, and then what do we have? Square root u du by 2x, where x and x cancels off. But what about the limits? Are the limits the same? The limits were for x, but now you have rechanged it. You substituted a lot of things and changed it up, right? So even the limits will change. Let's see how the limits will change. Say this u function, because now it's not in terms of x, it is in terms of u. So what is u of this limit 0? Basically, it was 0 if it was x, right? So we just put over here, wherever that u substitution, we have assumed the u value. Over there, put the x value as 0 because the initial values of 0 was supposed to be for x. So it will be 0 squared plus 1, that is equal to 1. What about u of 2? That is the upper limit. That will be 2 squared plus 1, that is 5. So now the lower limit is 1 and 5. The limits also change. This is the important part in this type of problems. Now we know it is 1 to 5. And what about this? 1 divided by 2 can be removed out, and we have square root u du. We can solve this up. It is u to the power half. I'll directly solve this up now. It's going to be half, and this is solved as u to the power half plus 1 will be 3 by 2. And over here, what's going to happen? Divided by 3 by 2, I'll just write it out. It'll be 2 divided by 3 plus c. These coefficients can be solved easily, but I forgot to write the limit here. Now the limit is very important. The limit for u, only the variable is from 1 to 5. That is plus c over here outside. Now you can avoid, now over here, instead of this plus c, I can avoid it. You do not need to write plus c. Why is that? Because the c and c cancels. I'll show you in a minute. Now let me simplify and write what is known. It's 1/3. I'm just writing it over here. U to the power 3 by 2, the limit 1 to 5. How do you apply the limit? It's upper limit minus the lower limit. So 1/3 is outside. Here, instead of u, you put this value, whatever is there. It is 5 to the power 3 by 2. It's not 5, sorry. It's 3 by 2. Yeah. 5 to the power 3 by 2 minus the lower limit, 1 to the power 3 by 2. Is that clear? Now, if we had the plus c, here it would be plus c minus of again plus c. It will be minus c, right? The cc value cancels. So you don't need to write it. Here plus c, and when you multiply the minus and be minus c, it cancels off. So for definite integrals, you do not need to put the in constant of integration. That c value is not there. Now what next? Let's just put this in the calculator. It'll be 1/3 multiplied by 5 raised to the power 3 divided by 2. It's not calc, I'm sorry. It's 3, power is 3 by 2. It's 1.5 minus 1 raised to 3 by 2 is 1 itself. It's 3.39. So the final answer would be 3.3934. This will be the limits after you apply the limits. So let's look into the answer. Now they have written in fraction forms. You can just leave it like that. I'll just explain what they have done over here. But this is absolutely correct. You need to do the step 1, use substitution. Step 2 is finding the new limits. So here the step 1 is this 1. Step 2 would be the new limits. Step 3 would be substitution. Step 4 would be the applying the limits and solving up. So this is all important. Now let me just explain why the solution set answer looks different. If you put this in the calculator, the answer will be same. I'll show you here. We have got 3.3934, isn't it? So let me just solve this up. It'll be 5 divided by 3 times root 5 minus 1/3, 1 divided by 3. It'll be the same thing. It's 3.3934. Why is it? Let me just show you. We had how much did we have? It's 5 3 by 2, isn't it? So 5 to the power 3, and it's a square root. So 5 to the power 3 is 125. That's why we have 125, and 1 raised to anything is 1. And we had 1/3 outside. This is why. And then what happened over here is 125, root of 125 can be written as 25 times 5. And 5 is a square, perfect square. You can write this as 5 root 5. If you put square root 125, I'm not sure in your calculators generally you get this form. You might even get you might get decimal or this form as well, radical form, you will get it. So this is the answer. Now you're multiplying 1/3 inside. So 1/3 over here will be 5/3 root 5 minus 1 times, it'll be 1/3. So that's why we got this answer. It's absolutely same. Whatever I'd written, that's more than enough. You can write in decimal point. It should be the correct answer. Or you can leave it over here at this step. What about the next problem? Let me solve this. What is u? Whatever is inside sine, we just take it as u. So u is pi x squared. Because we can easily solve sine u, isn't it? Now let's derive this. Pi is a constant, so du by dx would be equal to 2x, and pi is a constant. Now let's write dx. Du would be 2 pi x. I've just written pi over here, 2x, 2 first, 2 pi x. That is equal to dx. This is not done. We need to do the step 2 for the limits. U of 1, because over here the option, first limit is, lower limit is 1, will be pi times 1 squared. That is pi itself. Pi times 1 squared is 1. 1 squared is 1 times pi is pi. What about the second limit? Here we'll have pi and 3 the whole square. So it'll be 3 squared is 9 pi. So these are the new limits. I hope you remember you can directly solve these definite integrals and calculate. You can type this out as it is, you'll get the answer. But since it's the writing exam, I'm solving it by writing. Now here the new limits formed are pi, 9 pi, and we have x sine u dx will be du by 2 pi x. X and x is cancelled. So what is remaining here? I'll remove the 1 by 2 pi outside, and you're remaining with pi 9 pi sine u du. We can easily solve this. The answer would be, if you solve it up, 1 by 2 pi. And here, when you integrate sine, it is minus cosine. So I'm just going to write minus outside. Cosine u, that's it. Plus c, I'm not going to write y because it's the definite integral. Now don't forget the limits. I just almost forgot. Pi to 9 pi. Now I'll just continue it up over here. Over here, I'm just continuing it. So we have minus 1 by 2 pi outside. What happens here? Make sure you apply the limit to cos u. So you're not going to substitute back this values or anything. No, we are just going to apply the new limits. So what we do over here is cosine 9 pi minus cosine pi. So this is what we need to solve. We can just put this in the calculator and we can find the answer. So let's see, it's minus 1. I'm not going to leave it in radical forms or anything. I'm just going to do it directly in the calculator. Whatever the answer is, you can just write, because all the steps are done. The step 1, step 2, and over here step 3. And now we apply the limit. That's the last step. Cosine 9 pi. Sorry, it's pi shift and the symbol here. Minus cosine pi only. Close the bracket. And make sure you convert to the radian. See, it's in degree mode. Shift mode 4 gives us radian. So that's the answer, because these two cancel off. Okay, they are coterminal angles. It's the same values basically. Cosine 9 pi and cosine pi. So the answer will be 0. So that's the final answer. Here you can see. That's it. We have to don't do what they have shown over here because they have not done the steps properly. It is very important for you to do the steps. The step 1, the step 2, step 3, and the final step. Let's move to the next type of problems. Again, it's the same limit problems. And over here, it looks complicated, but all you need to do is whatever is down, just put it as u. U is equal to t squared plus 1. du by dt would be 2t. And du by 2t is equal to, sorry, du by, 2t is equal to dt. But it's not over. We have to find the new limits. So u of negative 1, the lower limit first, would be minus 1 the whole squared plus 1. And u of positive 1 is also the same thing, 1 squared plus 1, because the squared, right, negative will become positive itself. It's 2 and 2. Now here, whenever you take the definite integral at the same limit, it's 0, because whatever the value minus the same value will be 0. But anyways, we'll do the steps. So what we do is this particular given function, you need to write it in order. I'm just not writing in order because I'm just solving all these problems here directly. What happens is integral, the new limits is 2 to 2. The upper value is t for now, but this down one is u squared and dt is du by 2t. So this t and t cancels off. So I'll just write it over here. What is remaining with you is integral 2 to 2, and you have only 1 by u squared du. When you solve this, this 2 comes up. It will be minus 3, minus 2, and when you add 1, it will be positive, negative 1 basically. So integral 2 to 2, it's going to be minus 2 plus 1. That's minus 1 divided by minus 1. I'll just write the sign outside the integral so I remember it. And I'm not going to write plus c because it's definite integrals. And what happens now? Here, all you need to do is apply the limit. So I'm sorry, you don't write integral once you apply the integral. So it's already done. The integration is done. So you just write like this, the limits. Now minus, let it be outside, 2 to the power minus 1 minus again 2 to the power minus 1. Doesn't matter what integration you got, whatever is this values, when you apply the same numbers and you subtract with the same numbers, it's 0. 2 minus 1, it's 1 by 2. Half minus half is 0. Doesn't matter what sign, it's 0. The answer will be 0 here. So these are the steps. Make sure you don't write directly 0. I mean, if you had written the statement, the lower limit, lower limit LL, okay, just abbreviation, and upper limit, that is UL, are same, hence integral will be 0. Integral, definite integral is equal to 0. You can write this. If it was me correcting over here, I would have given you full marks because you understood over here there's no point in solving. Even if you solve, it'll be a 0. But it's, to be on the safer side, it's better to write the steps because it's anyways you know how to solve it. So just write the steps and it'll be 0 here. What about the next problem? Here, let us take t to the power 3 as u, because when I derive it, I'm going to get t to the power 2, and I can simplify this. I can cancel it off. So here u is equal to t to the power 3, du by dt is equal to 3t squared, and du by 3t is equal to dt. It's not over. What is the lower limit? U of 0 will be 0 to the power 3, that is equal to 0. What about the upper limit? It's 2, so it'll be 2 to the power 3, it's 8. That's the answers. Now the value over here changes to 0 to 8 t squared e to the power u du by it's 3t power 2. So this cancels off. What happens? 0 to 8 over here, it's 1/3. And then what do we have is EU du. Let's apply the integral. When you apply the integral, it's just the same thing because EU integration is EU itself. But we are applied from 0 to 8. No need of writing plus c. Here 1/3 remains whatever is the limit. We are applying the upper limit first. It's not 8. It is e to the power 8 minus e to the power 0. Anything to the power 0 is 1. So you can just write 1/3 into e power 8 minus 1 is the answer. You can put that in the calculator or you can leave it over here. It's fine, because you applied the limit. Even if you leave after just applying the limit, you must get the full marks. So now what I will do is I'll just type it out. 1/3 multiplied with e is, I can just press shift and ln. You get e to the power 8 minus 1, close the bracket. Reason is e to the power 0 is 1. It's 993.31, but let's see how they have solved it. This they have written directly 0 because of the same limits. Now here we have got 1/3 e to the power 8 minus 1. They have just left it over there. You can also do the same. Or you can even write the value in the next step. Now these problems, okay, this is pretty easy. I'll first solve the 36th one. Whatever is in the denominator, make it equal to u, 1 plus e to the power x. So why do we do that? Because when we derive e to the power x, is the same thing. So du by dx would be only e to the power x. It's 0 plus e to the power x. So du by e to the power x will be dx. Now don't forget the limits. It changes. What happens over here? U of 0, use the first initial assumption of u. That is 1 plus e to the power 0. And what if it's u to the power 2? It's 1 plus e to the power 2. Now for here, rather than substituting and solving, I'll just leave it like this only. For this one, I'm going to leave it like this. But what about the first one? It's 1 plus 1. E to the power 0 is 1. So it's going to be 2. So it's e to the power 0, that's 1. 1 plus 1 is 2. So it's 2 to 1 plus e squared. So the new limits formed are 2, 1 plus e squared. And what about this? Here, let's do the substitutions. E to the power x divided by u will be du by e to the power x. E to the power x cancels off. So you're just remaining with 2 to 1 plus e squared. 1 by u du. What is 1 by u value? It is ln u. Now you need to apply the limits. 1 plus e to the power squared is the upper limit, and down we have just 2. And let's apply over here. ln u is 1 plus e squared minus ln 2. So you can leave it over there because that must be the answer. Let's just look at the second answer first. Okay, they have used the properties. Now that's correct what we have done. Absolutely correct. But what is the property of natural logarithm? When you have minus, these terms can be written as division, right? ln 1 plus e squared divided by 2. That is the final answer. This is the simplified form because we are using ln a minus ln b is equal to ln a divided by b. I'll write the rule. If it's ln a minus ln b, sorry, not that. This is equal to ln a divided by b. This is the rule. So that is what we have applied over here. Therefore, the answer you can see is over here. That was an easy one, but what about the first one? It's a little bit different, right? Because we don't have e to the power x over here. So what we will do is, here, if you take e to the power 2x as u, it's not going to work out. Why? Because if you take like this, it's going to be 2e to the power 2x itself when we derive it. And we can't cancel each other out. So what can we do? Okay, what if I take e to the power x as u will be e to the power x. Let me derive it. It'll be du divided by dx is e to the power x. Now du by e to the power x is equal to dx. Okay, I can cancel this ex, but u is only that. So I can't do u substitution and then I'll just get extra variable. But what if I square the first given term? U is equal to e to the power x, right? What if I square this up? U squared will be e to the power 2x. Now, what if I write over here as u squared? That will work, absolutely. And what about the limits? So limits would be u of 0 and u of 2. First one will be, now here, don't write in the second equation, not u squared. We have to look at the u, whatever we substituted over there. It'll be e to the power 0, that's 1. And over here, it'll be e to the power 2, that's e to the power 2 itself. That's it. So this is what we do. Now we got the new limits. So e equals to, from 1 to e squared. What is this e to the power x? Let's write it just like that. Don't put it as u, because our goal is to cancel this off and we have this as u power 2. Whereas this will be du by e to the power x. But if you put this as u, then again put u and then it cancels off. You can do it like that, but it's better to leave it. And now it cancels off. So what is remaining here? 1, from here I've written down over here, e to the power 2, that's e squared. And we have 1 by 1 plus u squared du. This is tan inverse, isn't it? So when I apply the integration, it will be tan inverse u, because 1 by 1 plus x squared is tan inverse x. The limits are e squared and 1 lower limit. So we apply the upper limit first. It will be tan inverse of e squared minus tan inverse of 1. That must be the answer. So if you look carefully, okay, tan inverse of 1, you can put that in the calculator, but that's the answer. Let me show you how you get the tan inverse of 1 as pi by 4. In your calculator, you can just press shift and tan, and then 1, it'll be 1 by 4 pi. That is 45 degrees. So that's tan inverse of 1 is 45 degrees. You should have, I mean, you might have known. You can directly write it or just use your calculators. And we do not need to simplify this because tan inverse of e to the power 2 is some weird value. Rather than that, we'll just leave it like this. Okay, like this over here. You can just finish this answer off by writing tan inverse e squared minus pi by 4. That's the final answer over here. That's it. So the first problem, we have to take u as e to the power x. But then when we are using the u substitution, we use u squared for the down term. And the above term gets cancelled off. So that is one thing you must remember. See, when it comes with exponential integrals, so remember these tricks. Whereas the second problem was pretty easier than the first one. It's all same, just the differences. Over here down, denominator, it was 1 plus ex in the second one, whereas the first problem is e2x. What about these? Now, cotangent. Do we have any rule for cotangent? No. But we know cotangent is cosine by sine. So here, first, the given question transforms to pi by 2, pi by 4. Cotangent is cosine x by sine x dx. Now, whatever is in the denominator, you consider to be u. u is sine x. And then what we do is derive this. Du by dx will be equal to it's cosine, positive cosine. Be careful, sometimes I get confused because we have derivatives, we have integrals, so you need to be thorough, practice more problems, then it will naturally come. You will not be confused with these identities. Now this is the derived one. It will be du by cosine x, that is equal to dx. But it's not over, we need to find the new limits. So u of pi by 4 will be equal to sine pi by 4, and u of pi by 2 will be equal to sine pi by 2. We will just substitute these values in the calculator. Here we will type sine pi by 4. It is pi divided by 4. Sorry, it is decimal here. Now, if it's not in radian mode, you have to press shift, mode, and 4. And then if you press equal to, you'll get this answer. Okay, what is this exactly? Root 2 by 2. The reason is when we solve this, it'll be natural logarithm when we have these problems. So it's better to write the actual form. Instead of root 2 by 2, this is equal to root 2 by root 2 root 2. What do I mean by this? 2 can be written as 2 times root 2. When you multiply, the square root cancels off. So it's the same thing. So I can cancel these both, and 1 by square root 2 is same as root 2 by 2. I will prove it by just pressing SD. It's 0.707, right? And 1 by root 2 is also the same thing. See, it's the same thing. So we can just write 1 by root 2. And what next? We have sine of pi by 2, which is 1. Pi by 2, it's shift pi, and divided by 2, it is 1. So we will write it out over here. I'm going to write 1 by root 2, and this is 1. Let me just clear this off. And even if you write root 2 by 2, it's okay. That's no problem, you know. What happens here? Here now, the limits are changed. The lower limit, pi by 4, we have 1 by root 2. And what about this? It's 1 over here, isn't it? The upper limit. And cosine remains for now. Sine is u. This dx will be du by cosine x. Cancels off. Your 1 by x du remaining. I'll directly solve using the integral. It'll be natural logarithm u. The limit is from 1 to 1 by root 2. Let's apply the upper limit. What happens? It'll be ln 1 minus ln 1 by root 2. Now, what is ln 1? If you remember, it's 0, or we can just use the calculator and solve it up. Here, natural logarithm ln 1, close the bracket, and the answer is 0. So the first part will be 0. It's just minus ln 1 by root 2. So that is the answer. You can leave it like that. So you can see the answer is, okay, they have simplified it further. I'll tell you how the simplification is done. Do you recall the property that is ln A minus ln B? What happens here? This is equal to ln A by B. Similarly, if it's A by B, that is one term divided by the other term, you can use this upper formula. So let me write this minus outside. And here we have ln 1 minus ln square root 2. ln 1 is 0, so it's minus of minus ln square root 2, which will be equal to ln square root 2. So this is the answer. If you're getting too much confused after this step, just put this entirely in the calculator. You will get the answer decimal. You can just write it over there. But this is the actual way to simplify, and this is the simplified version. If you're aiming for a perfect score, like perfectly understand this, then I would suggest you understand how it's done, and then you only can solve it until over here. So ln square root 2 is the final answer. That's over here as well. What about this problem here? Now this is pretty easy because you can see ln x is more complicated term. So if we take this as u, we can easily eliminate x because derivation of ln x is 1 by x. Let's assume u to be natural logarithm of x. and du by dx will be equal to 1 by x. So what is du? That is dx, but the x multiplies with du. It's not over. U of 1 is equal to ln of 1, that is 0. And what about u of e? So this is ln e. What is natural logarithm of e? It is 1. Why? Because they're inverse of each other. They cancel off. It's 1. So it's 0 to 1, the limits. So here the limits turn out to be 0 and 1. The lower limit, when we apply 1, it's 0. When you apply e, it is 1. Now let's write natural logarithm. That's u here. U divided by what is x? Let's write it for now. But the dx is converted to x times du, right? So x is cancelled off. So you have 0 to 1 u du. What's the answer? It's u squared by 2. Apply the limit from 1 and 0. So I'll take this half outside, and you're remaining with u squared of 1 and 0. This is for the u squared. Half of 1 squared minus 0 squared. The answer is 1 only over here, so it's half. So that's the answer. These are the exact steps. You can skip many steps, just in the mind, you can from here directly jump down to here as well. Half is written outside, 1 square minus 0 squared. So you don't need to do all the steps, but if you want, you can follow that. So the answer is half for the next one. And the first one we did, it was natural logarithm root 2. We have reached the last two problems. I'm not sure anyone has stuck through all the video. It's such a long video. But if you have really watched the entire thing, then well and good. I'm sure you might have understood the integration by parts thoroughly. So let's complete the last two problems now. Here, what we need to do is, you can see, we do not need to substitute anything. We can just simplify this directly. Don't get confused because we are doing all u substitution. Don't jump to the substitution part. Here, firstly, 1, 4. What happens? It's x divided by root x minus 1 by root x. This all dx. So here it's x power half. You can write it as x, this is 1 minus half. And over here, this x half, right? Just bring it up. It'll be x minus half. 1 by root x is 1 by x to the power half. That's positive. When you bring it to the numerator, it becomes negative. This all thing dx. So we have simplified it to x power positive half minus x power negative half dx. Let's just apply the integral directly because we know the integration for both of these, and we'll get the answers. Here integration will be 3 by 2 and outside will be 2 by 3. You have done this before, and the limit over here will be from 4 to 1 minus, here it's going to be positive half, and the 2 divided by 1, I'll just write 2 over here, and the limit over here is 4 and 1 itself. So what's going to happen here? It's 2/3 of 4 3 by 2 minus 1. 1 3 it's upper limit minus lower limit. Doesn't matter what you have to the power of 1, it's 1 itself. So I leave it over there. Minus 2 times, what is it over here? It's 4 to the power half minus 1. So this is the final answer. You can simplify it. I'm not sure they might have left it like this. Okay, they have simplified it to 8 by 3. Let me do that as well. Here what happens is, see, instead of simplifying like that, I'll just put this entirely in the calculator. It'll just save you time. 2 by 3, open the brackets, 4 to the power 3 by 2 or 1.5 minus 1, close the bracket, minus again 2 times, open the bracket. You can write multiply over here, or even if you don't multiply, it's automatically multiplied. It's not squared, it is 1 divided by 2, and it's again minus 1. Close the bracket. The answer is 8 by 3. Directly you get it in the calculator because 8 by 3 is a simple fraction. It'll be shown. So that's the answer. As long as you have done these steps, proper steps, you must get proper marks, full marks for this. What about, over here, you can remove these terms common out and then solve. There are various methods to do it, so that's why, you can follow whichever is convenient for you. What about this one? It's again another simple problem. Let's do the last one here. Whatever's inside the square root, I'll substitute it as u, that is equal to x squared plus 1. And du by dx would be equal to 2x. And du by 2x would be equal to dx. Next, we have to take the limits of u of 0, that will be equal to 0 squared plus 1, that is 1. And u of 1 will be 1 squared plus 1, that is 2. Now this entire question transforms to the limit. Lower limit is 1, upper limit is 2. And we have x divided by square root u du by 2x. This x and x cancels off. And you're remaining with 1 to 2 half. I'm going to write it outside. This divide by 2, half is written outside. U is power half. I'll take it up. It's going to be negative power half. Why? Because square root is power half, right? I took it up. It becomes minus half du. And then let's apply the limits. It'll be half. Let's apply integration. Sorry, not the limits. It'll be u to the power half positive, and divided by half, the 2 comes out over here. It's all multiplied, and the limit is from 1 to 2. 2 and 2 cancels off, so you're just remaining with u to the power half with the limit of 1 to 2. Now let me do it. 2 half minus 1. It is basically square root 2 minus 1. This is the final answer. So here we go. Yes, that's the final answer. And that is the end of all the writing part questions. I hope you have found these videos helpful and beneficial. I wish you all the best for your exams. Please do prepare well in advance for your exams. Don't leave it at the last minute. And if you have any doubts, please try rewatching the video or ask your questions in the comments, and I'll try to get back to you very soon. And thank you very much for your support for my channel. I'm really humbled by all the appreciation and thanks I receive on the channel. Thank you so much. I really appreciate it. If you could do me a huge favor, then please do share this channel with anyone who do not know about this and who could benefit from it. And if you can, please do hit the subscribe button and like my videos. It would mean a lot. Thank you very much, and bye-bye for now.